right, looks like we are live, and I want to welcome everybody to Standing for Truth. My name is Donny, and I am here with my co-hosts, Matt and Sam from Team Standing for Truth. We are here for another epic evolution open mic discussion and debate and Q&A. We will be interacting with our live audience tonight as well. And it is a privilege to have the man, the myth, the legend, the undefeated champ, Dr. Dino, with us for this exciting program. Kent, it's great to have you, brother, as usual. And before we get into it, I want to ask you, how many debates have you had so far? At least 320, right?
I believe this is number 328 tonight. If any atheists show up, I'll take them all on 10, 20, 30, 40, 200 at one. It's real simple. I'm right. They're wrong.
Exactly. I like how you keep it simple, brother. So now in all of those 327 or 28 debates, have you found any of their so-called lines of evidence to be even remotely convincing to say that we're related to banana plants? That is, Kent.
So far, nothing. For a millionaire one time years ago, he said, "Bro, when you make the offer, I'll back you up. If anybody provides any real evidence for evolution, I'll pay him $250,000. And so we did that for years. Nobody ever gave any evidence. There's no evidence for evolution. None. Zero. If you think there is, call in.
Well said. Well said. So we're going to keep this, as Kent said, this will be an open mic. And so what we're going to be doing specifically tonight is debunking evidence for evolution. And so I have what Matt, Sam, and I have put together is several videos from evolutionists presenting their idea of what is good evidence to say that strawberries and whales are related. We'll engage those a little bit and have some fun with that. I've also got an article from BioLogos, a well-known theistic evolutionism organization, and we'll cover a little bit on what they believe is the best evidence for evolution. I will also post the link in the live chat for people to join. Now, you can either join for impromptu debate. And so if you're an evolutionist and you want to present your best evidence for evolution, click the link. I will make sure to keep it one topic at a time. We're going to keep it cordial and respectful. Or if you're a creationist and you just want to ask a question, then feel free to click the link and join as well. Now, I want to make sure that everybody knows that anybody who joins, questions end in question marks. So no stories, no monologues. Feel free to join, ask your question, and we'll let Dr. Dino answer them. And so before we get into the first video that I think we'll respond to, Sam and Matt, good to have you gentlemen with us as co-hosts. Matt, I see you've got your Nobel Prize with you, so that's great. Sam, let's start with you, brother. Any words of introduction?
No, hey, look, I'm glad to be here. It's a pleasure to be here with you fellas, and so thanks for having me on. I'm excited.
My pleasure. You're always a great moderator, and you've always got good insight, Sam.
Thanks.
So, Matt, good to have you as well, brother. How you doing?
Oh, thanks for unmuting. Doing good. Excited about my debates you've set up for me as well, coming up this month. That'll be fun.
You've got two debates coming up, Mark Reed and Grayson, who Kent is familiar with. Kent's debated each of them 3 times. So that should be fun. Matt, are you excited about Kent's boot camp next week?
Yeah. I wish I lived closer. I'm like as far away as you can get in the United States anyway. But I'll make one of these.
We've got some good information to present for you, Dr. Dino. So, Kent, I'll hand it over to you in case you had any words of introduction. Why don't you introduce yourself a little bit, and then I think we'll just get right into it.
All right. Well, I'm just an ordinary fellow living in Lenox, Alabama, straight north of Pensacola, 70 miles. I've been a Baptist preacher 49 years. I taught high school science and math for 15 years. And we've made probably 15 or 18 million videos on science and the Bible, defending the Bible as being scientifically accurate. Videos and then later DVDs. And a guy watched one of my videos, called me 7 years and 2 months ago. He said, "Kent, your video changed my life." And bottom line is he ended up buying this property for us here in Lenox. I was in Pensacola for 30 years. He bought 140 acres, $250,000, gave it to us. I've never met him. He lives in Missouri is all I know. Anyway, it's been amazing watching this place to come together, brother. We've had visitors from 71 countries, all 50 states. We just have a science center that's 12,000 square feet of cool stuff on science and the Bible. A safari tour that I give around 16 lakes for fishing and boating. all kinds of fun stuff to do. We try to make everything have a science lesson with a spiritual lesson, like Jesus would do. Consider the lilies, consider the ravens, consider the sparrows, or Solomon, consider the ant. There's all kinds of things in nature that'll draw you closer to the Lord. So come on down. We'll give you the tour. It's all free. Has been since we started 7 years ago.
Awesome, Kent. Thank you for the introduction. First question I will ask, and then I'm going to get into a couple arguments from Professor Dave, who I think we are all familiar with. Actually, first question that I'll have, since we're going to be playing some of Professor Dave's clips here. Did you get a chance to see his debate with Dr. James Tour, and what were your brief thoughts on that, Kent?
I saw quite a bit of it. They both interrupted each other constantly, which is sad on both parts, okay? But Dave is just, he'll interrupt every word. That's why I insist, if we have a debate, one topic at a time, no interrupting, equal time for both sides. I'll take on Dave. He's not a professor. I'll take on Dave anytime, okay? If we have followed those simple rules. He goes first, present the best evidence for evolution. I thought Dr. Tour slaughtered him when it comes to the real science.
Right.
There is no scientific evidence from chemistry of life being able to create itself. And that's what Dave believes. It's just dumb. No better way to say it, dumb.
Life from non-living chemicals, and then that life evolved over time indirectly through lots of mutations and natural selection into whales and humans. So a lot of science fiction, but that is why evolutionists in the live chat tonight is your opportunity to join us and engage the topic of creation and evolution. I've already got many people backstage, so this should be fun. Matt, Sam, and Kent and I are just going to have a little fun for about 10 to 15 minutes, then we'll let people in. So my question to you, Kent, is a lot of evolutionists, they'll point to what's called a nested hierarchy. They'll say, well, if humans and chimpanzees aren't related through common descent or common ancestry, why are we as humans most similar to chimpanzees in the biological world than any other form of life, let's say a dog or a whale?
Okay, the entire classification system, putting animals or plants into groups, you know, the ravens and the crow, or the bobcats and the lions. The animals don't care about this at all. This is completely a man-made classification system. They don't care. Turn all the animals in the world loose into the woods. The squirrels go looking for another squirrel to mate with. They don't look for the pine trees or the bananas or the raccoons. They know what their kind is. This whole thing is man trying to impose our ideas onto the animals. They don't care. There are 12,000 now varieties of apples that farmers have developed. Some grow better in sandy soil, some in rich, different kinds of soil, some in cold climate, some in warm climate, some are sweeter, some are juicier. I don't care. The apple doesn't care, okay? The apple pollen, you can sprinkle it all over the fish and nothing will happen. They won't. They can't crossbreed with the fish. They know what their kind is. God said 24 times in the first 7 chapters of the Bible, the plants and animals would bring forth after their kind. That's all anybody's ever seen. No farmer in the history of the world has ever seen a cow produce a non-cow or a dog produce a non-dog. We might get some weird varieties, but it's still the same kind, and it's recognizable to a 4-year-old as the same kind. But the whole classification idea is man's idea. The animals do not care at all. So I think it's absolutely silly to call it a nested hierarchy that we're in. Who decided we're in with the chimpanzees and the baboons? They don't want us. Tell you what, turn them all loose. The chimpanzees go look for another chimpanzee. They don't look for a human, ever. You may find some weirdo humans might look for a chimpanzee, out on the left coast, but I won't mention any states. But yeah, there are some plenty of screwballs out there, but they know what their kind is. It is this whole nested hierarchy and classification system that Carolus Linnaeus made up. Look, it's handy, it's nice, it's great. We have all of our screws in one place of our shop. We have another place for bolts, another place for nuts. Now, certain nuts will fit on certain bolts. The fact that we've got all the bolts in one pile, does that mean the 1/4-inch bolt would work on a 3/8 nut? No. The nuts and bolts know which one they fit, okay? This whole idea of nested hierarchy, I think, is taken way, it's out of control, okay? It's used as evidence we're related. That is so stupid. Tell them I said so. Real stupid.
Great response. And is it really a surprise to the creationist, Kent, that if we were to line up, let's say, a human with a chimpanzee and a banana plant, is it really any surprise that we would share more in, let's say, physiology or genetics with the chimpanzee than a banana plant? I mean, just look at the outward appearance. There's more similarity in general.
Right. Well, we all have the same designer is why there's similarities. We all have DNA code. I got 10,000 books in my library here. All of them use the same basic code, 26 letters of the English alphabet. It doesn't prove anything. It doesn't prove they're related. That's the code with which you write English. The code that we write our DNA code with is those, CATG. And that's, if we weren't similar in some ways to other plants or animals, we could only eat each other. The fact that the brown cow can eat the green grass and give the white milk, and I churn it and get the yellow butter, and I eat it and get the blonde hair, that's proof of a common designer, not proof of relationship. How can they not see that? It's necessary that there be some similarities so we can live together in the same world. We all breathe the same gas, breathe in the use up the oxygen, give off the CO2. The plants breathe in the CO2 and give off the oxygen. Is that proof of something? It's a neat design. It works really well. I think it was designed that way. So the evidence that they use for evolution, I've never seen any. It's all much better explained by a creator. I could point out that quite a few of the Bic ink pens have similarities. Ballpoint pens have have a ball in the end. Whoa, what does that prove? The same guys designed them. It's a good design. It works well. It rolls around in the ink and brings it out of the cartridge. It's not evidence for relationship. It's a common. I was driving around today, and all the cars I saw had round tires. All of them. Every one. Does that prove they're related? No. It's a common design. It works well. They don't get it. I've given up hope on them getting it. I still do the debates because I want to reach some of their audience, okay? But I think they've lost their mind. Here, I tell them, I found what you're looking for. You guys who believe in evolution have lost your marbles. I got them right here. I'll keep them for you. Come visit Dinosaur Adventureland. You have lost your marbles. I got them.
Well, like you said, every single mode of transportation that comes with four wheels proves that they all descended from a skateboard millions to billions of years ago, Kent. So that's their logic, right. Basically.
I know.
Now, before I bring people in, I'm going to go through one portion of, because we've got a full house backstage. So that's good. We probably won't be able to get through too many of these clips we have. But that's why we can do another show on this in the future. Sure. So let's play a little bit from Professor Dave. We'll get your response, Kent, and then we will start bringing people in and having some fun. So here we go. I'm going to mute. We'll just play a little bit of Professor Dave, and then we'll allow Dr. Dino to respond.
Here we go. Let's begin by stating that evolution by natural selection is an observable fact. Expose some bacteria to antibiotics, chance mutations lead to resistant ones, the rest die, and soon they're all descended from the resistant ones. That's evolution by natural selection. Speciation.
Yeah, please stop it about every 3 seconds so I can make some comments, okay?
One at a time. Go ahead, Kent.
For him to just make that blanket statement and just move right on, this is how they bamboozle their students. Wow, the teacher said it's a fact. Natural selection, listen to me, Dave, selects. It doesn't create anything. It selects. I can go through our shop and pick out all the screws. I selected all the screws, okay? A farmer can go through his herd of cows and select the ones that give more milk, and they'll only breed them next time. And eventually you get a cow that gives 185 pounds of milk a day. That's now the world record, I believe. It's utterly ridiculous. So it's still a cow. It's still giving milk. There's natural selection where nature decides that one won't survive. And there's artificial selection where a human being survives or selects the one. Either way, it's a selection process. It's not creating anything. Natural selection, if you take an antibiotic and it kills 99% of the bad guys, the 1% get to survive and go make the next generation. It didn't change it to anything else. That process won't change a bacteria to a whale. They just, I don't know how to get them to see it. It selects. It doesn't create anything. So natural selection is an observable fact. If you turned all the dogs in the world loose in Alaska, only the ones with long hair, thick fur, big, dense body instead of skinny body to hold the heat better. It's a surface area to volume ratio problem. They would survive. My wife's pug wouldn't go 3 minutes up there. The squirrels would eat it, okay? So nature will select some to not make it. It's still a dog, and it's all it's ever going to be. They think it's a creative process. No, Dave, it's a selection process that keeps the species strong. It doesn't create anything. Go ahead.
Well said. It's a fine-tuning mechanism that keeps a species as strong as it can be. It's not adding anything. It's survival of the fittest, not arrival of the fittest.
Right.
Fittest. Okay, let's go on to the next point. See, it's nice when you can mute him, or you can pause it, right, Kent? And then go one point at a time with Dave. Okay, here we go. Next point.
Or the production of new biological species is also an observable fact. We have observed the emergence of new species of microorganisms, plants, and animals. We know so much about it that we have terminology to describe the different kinds of speciation that can occur. If you understand biochemistry, none of this is surprising at all. DNA undergoes.
Okay. Who is defining when something becomes a new species? Are a dog and a wolf a different species? Yeah. Are they still capable of interbreeding? Yeah. Does that prove they're related to pine trees? No. God said they bring forth after their kind. He didn't use the word species. I don't think the animals care how we classify them. They don't care at all. They know to look for their own kind. Every plant does that. Take the pollen from a pine tree and sprinkle it on an oak tree. Nothing will happen. So speciation, the word is what's confusing. They're still the same kind of animal. Nobody's ever observed any of these speciation events like the fruit fly becoming anything other than a fly. They spent thousands of dollars in the laboratory on them poor flies, nuking them, microwaving them, x-raying them, trying to make them make mutated babies. And they succeeded. They got flies with no wings. What do you call that, a crawl? They got flies with curled wings, can't fly at all. They got all kinds of mutations. They never got anything but a fly, and they never got any improvement. All they're doing is wasting tax dollars on dumb experiments to try to prove their religion. Evolution is a religion. So natural selection is not going to create anything. It selects. And speciation, the farmers get all excited. Wow, I created there are now 400 breeds of cows. You want to use the word breed or variety or species or kind, it's still a cow. Still a cow. They've never seen anything go outside what any 4-year-old would consider a new kind of animal. None. So Dave is dreaming. Go ahead.
Dave hopes, dreams, and imagines that he's related to a pine tree cat. I wrote a book, great points, called Special Creation. Matt and I did a lot of work on these so-called speciation events. And we discovered that, and Matt, correct me if I'm wrong, the majority of the time that these new variations arise, it's due to a reduction in genetic variability. It's not adding anything. We don't see uphill changes. It's all what I would call horizontal changes within the genomes. Matt, if you could touch on that briefly.
Yeah, matter of fact, as long as the species is alive today and we can test it, I think that would be a great indicator for how we could determine what animal kind was on the ark. Because if we only see chromosome fusions and genetic decay, then theoretically we should be able to go backwards in time and look at the animals that have the highest amount of chromosomes and say, look, that animal was probably on the ark. Now, if that species had gone extinct, obviously we couldn't know that. But if we look at all the different animal kinds that are out there and we keep seeing genetic loss, gene loss, mutation affecting a creature, then sure, we can go backwards in time and we see superiority of animals. That's not what evolution is supposed to be doing, right? We're supposed to be moving in this linear pattern like a tree from the root of a primitive common ancestor and branching up. Well, we don't see that anymore. So what do? They say, well, that type of evolution isn't happening anymore. We're on the tips of the nodes of branches. We're seeing exactly what you creationists are talking about, but it doesn't mean that the other didn't happen a long time ago. So they're kind of faith-based on that, right? So what we see is, chromosome fusions, genetic loss, chromosomes getting smaller, the genome getting smaller. So I say just go backwards in time. We can trace those kind right to the ark, and I've done it with a couple.
So basically, You're basically saying that species over time hit walls. If we're going to say all of your domestic dogs, Ken, if you would agree, go back to a common canid or wolf-like ancestor. Well, a wolf-like ancestor to a Chihuahua, I mean, that is a reduction in many ways. That is not improvement. You put all the Chihuahuas back into the wild, Kent, you've pointed out that they probably wouldn't last a week. They'd get eaten by the squirrels.
Right. And they're still a dog, and there's a limit. They've been trying to get smaller dogs. Let's say they got down to the toy Chihuahua. Do you think they'll ever get a dog as small as a flea? There are life forms as small as a flea, like a flea.
Right.
Is there a limit to the dog variations? They got now the big Mastiff dog, the huge dog. Do you think you'll ever get a dog as big as an elephant? No. They don't admit this. Yes, you get varieties, but there's a limit. They don't like that at all. They think because we see 400 breeds of cows, therefore cows are related to pine trees.
Right.
It seems like you could have. It seems like you could still have two creatures that derive from the same genetic created gene pool, but maybe now that we're further down the line, they might not be sexually compatible. You know, maybe they've been separated and something has lost something where now it's no longer separated. But yeah, it doesn't mean that it didn't derive from the same created gene pool.
Right. Okay. Good points, gentlemen. Appreciate it. We'll go, let's say one more point. Looks like, quote unquote, Professor Dave is going to touch on mutations. We'll give Kent the opportunity to respond, and then we'll start bringing people in. And to notify the live audience, if you do have questions, but you don't want to join the stream, tag me. I'll save them. If we get a chance, we'll get to them. Also, the link is posted. And so click the link. I will vet you backstage. If I don't know who you are, I'll just ask for a little bit of information before I bring in, and then we'll have some fun. So here we go. I am going to share screen again. We'll go to Professor Dave's next argument. So far, he's 0 for 2. And so let's see if he's 1 for 3.
Mutation. New genes means the expression of new proteins with the potential for novel functionality and eventually completely different organisms. This happens faster than one might think. Even a single point mutation can produce legs where antennae should be, additional sets of wings, and other remarkable changes. Kent will respond by saying that these are never different kinds of organisms. Well, what is a kind? This word is in the Bible, but it's incredibly vague. We can read about cattle.
Let's stop there. He's basically pointing to, Kent, as you can tell, he's saying, well, we've got mutation. So we have natural selection that acts upon that which exists, the genetic variation that exists, but mutations, they'll add the necessary genetic variation for selection to act on to basically have evolution taking place.
Okay, a mutation might be similar to if you're typing in, say, a Word document and you have a typographical error. You make a mistake. Oh, or you transpose 2 words. Like, please throw Grandma down the stairs her hat. What exactly does that mean? We throw Grandma down the stairs, or we throw the hat down the stairs? So you could cut and paste and mix up words, okay, and mix up sentences. Mutations is a scrambling, listen to me, Dave, it's a scrambling of already existing information. It's not creating new information. Show me a mutation that made something beneficial that added new information. There are lots of mutations. Nobody argues about that. All of them are harmful, fatal, or neutral. They do nothing. We got a couple of ducks I feed a couple times a day when I give my tours here. They got feathers growing out of the side of their head. It's a mutation. The bones of the head didn't grow together right, so they're mutated. They're still a duck, and they're still stupid like the rest of them, but it's not helpful. Nobody's seen a good mutation. Somebody said sickle cell anemia. Oh, that you call that a good mutation? They say, yeah, you can't get malaria if you got sickle cell. Oh, you cut off your feet, you can't get athlete's foot either. Is that a good mutation? All they are, mutations is a scrambling of already existing code. That's all it is. That code is more complex than the space shuttle. You know, we use a 2-digit Morse code, you know, dots and dashes. DNA uses a 4-digit code, you know, the CATG. You can write 1 trillion times more complexity with those codes, and they have. That's what all the different plants and animals are made from. And again, if we didn't have some similarities, we could only eat each other. How is it you can eat the meat from the brown cow and digest it? There's similarities. Their protein is similar enough. You can digest it, break it down, make it into your protein. Great. That's not evolution. So I'm sorry, Dave, you're wrong. That's not evidence for evolution.
Right. Just like the sickle cell anemia example that you brought up, Kent, that is due to a broken protein. It's due to a deformed hemoglobin protein. And so this is, again, a loss. It's functionally compromising overall to the organism. So you're not going to take your fish to fisherman through degradation over time. I don't think, if you could speak to this a little bit, Ken, I don't think Professor Dave realizes that today biological organisms have a very high genetic load. We have been accumulating mutations for thousands of years. Most mutations are deleterious. And so deleterious mutation accumulation, again, is not going to take your single-celled like ancestor into a whale over time. Ken, if you could speak to that briefly.
Yeah, see, they're not adding information. They're scrambling existing information. Like the birds, the different kind of feathers on the birds. They already had a feather. Or like the cow that gives 185 pounds of milk a day. It was already giving milk. It didn't create anything new. It didn't get wings on the cow. All mutations do not produce any kind of evolution. They've known this for 50 years. All it does is scramble existing information. That's all it does. So I'm sorry, Dave, you're wrong again. But Dave thinks he's a strawberry. So, I mean, what do you expect?
Right. Actually, Kent, what we'll do is we'll talk a little bit about that, and then I'm going to bring in our first guest. So, Kent, you've got a pretty cool tree of life of all of the evolutionists that you've debated. Professor Dave, who we're talking about now, he believes he's related to
Professor Dave.
Isn't that right?
Yeah, Professor Dave. Where's he at on here? Oh, here he is. Snake was right. There he is. Professor Dave is a strawberry. Snake was right. I said, are you related to a ladybug? He said, oh, yeah. Okay. Tom Jump. I said, are you related to a tomato? Oh, yeah, I'm related to a tomato. Let's see. Ken Rock is related to a turtle. Luca related to a cow. Wade the Wizard related to a snail. I got them all on a chart. I ask them, are you related to this? Ask an atheist, are you related to a buzzard? Oh, yeah. You related to a worm? Oh, yeah. They think they're related to everything. And when I show them that they really believe they all came from a rock, then I say, now, how can you guys in good conscience drive on the highway that's made out of your ancestors, for heaven's sake?
Disrespectful.
Show some respect. Gee whiz. I love it. Go ahead.
Matt, if you were an evolutionist, what would you like to be related to?
Ooh, something that's treated really nice. Maybe his wife's pug. Be carried around everywhere. Just I don't have to walk. They bring me food.
Right, they do everything for you. Yeah.
I guess Kent's pug will work.
What about you, Sam? What do you want to? Yeah, Kent, go ahead.
Matt, you can have the pug. Where do you want me to send it?
Just go missing one day, huh?
Oh yeah, I'd say something similar. Just lay around, some pet.
Yeah.
Yeah, they got it made.
Got it made.
Okay.
What's for dinner?
And Kent, sometimes during your debates, you get your evolutionists that are really reluctant to admit that they believe they are related to mosquitoes and walking sticks and fish. But eventually, after enough of the right questions are asked, they will finally admit to the fact that they believe they are. It was Darwin who said, isn't it a fact, or isn't it a reality that all plants and all animals should be related? Well, you've got animals like whales and plants like banana plants and strawberries. And so that's exactly what Darwin is saying. Isn't that right, Kent?
They put them on these family trees. The kids have to learn this for school. This is not science. They think a protozoa turned to a biology teacher and you're related to a jellyfish. They make these trees of life, and all it is a bunch of lines on paper. It's not science. Here they got the humans related to a pine tree. Yep, that's proof right there. They draw these lines. The kids see it in the textbook. Wow, it's got to be true. It's in my textbook. You're a primate. Oh, really? Yeah. This is a brainwashing program that's been going on for 150 years now, and it's time we put a stop to it. If you want to believe you're related to a strawberry, go ahead. Don't teach that as science.
Well, Kent, let me ask you, what if we put more lines on the paper and arrange them in a more sophisticated way? Huh? What about that?
That might make it true. You're right. Let's see.
Right.
The bird and the mouse are related. Who'd have thunk it? Look at that. Wow. This is the
Right.
stuff they do. It's sad. Go ahead.
Kent, what if we were to, like Sam said, what if we were to make the tree look something more like this? A lot more lines, looks a lot more complicated, a lot more sophisticated. Does that change the fact? Does that mean, okay, maybe we are related to apples?
That's what they do. And it overwhelms the students. They got to memorize all this stuff for the test. One guy called me last week. He said, Brother Hovind, my daughter is, I forget, junior high, I think. The last question on their final exam was, do you believe evolution is the best theory to explain everything? Yes or no? And it was worth 30% of the grade. He said, Brother Hovind, what should I tell my kid? I tell the kids, you should say, the textbook says, but I don't believe it. But this one didn't give that option. It was simple, check yes or check no. What's the student supposed to do? If they check no and the teacher marks it wrong, now they just lost 30 points out of 100. They're going to fail. That's how to weed them out. I said, send me the name of the teacher, the name of the book, a copy of this test. I want to get a lawsuit going on that one. That's somebody pushing their religion at taxpayer expense. That's all it is. Evolution is a religion. Nobody ever sees any of this. None. But they somehow got all of us paying for it. Well, I'm not happy about it.
It's propaganda. You pointed out the question. It's like if I were to ask you, are elephants pink or orange? Well, they're neither. It's a bad question. And I think this all goes back to the creationist model. If by evolution they mean change over time, then sure, my cell phone changes over time, cars change over time, various creatures change over time. Look at all the domestic dogs that we see today. And so if by evolution they mean domestic dogs, wolves, and coyotes are related, then we're probably not going to have a problem, right, Kent? But if by evolution they mean dogs, wolves, banana plants, and flowers are related, then that's where we have an issue.
That's where one of the first things I always do in my debates is I define exactly what do you mean by that word evolution, because it's a slippery word. Are you talking about cosmic evolution, the origin of time, space, matter? That's not science. Chemical evolution, stellar, organic, life getting started. That was the Tour debate. That was classic. Macroevolution, where an animal changes to something else. Those first 5 definitions are purely religious. They're not science. Microevolution is a lousy word. We shouldn't use it, but they do. All it means is a variation within the kind. That's all we've ever seen. That one is science. The first 5 are religious. So you got to define what exactly are you talking about? What do you mean by evolution? The word is more slippery than people realize.
Amen. That's why it's important to define terms. So before I bring in my first guest, somebody's pointing out the Tweety bird that you have in your background, Matt. So when you look at those Tweety birds, do you see the relationship that the evolutionists are speaking of? Do you see the similarities? Do you see how that is possibly your cousin, according to them?
I mean, that's
he just said amen. Yeah.
That's a Tyrannosaurus for sure. I could say I can see the similarity. He definitely weighed about 30 tons in the past. There's no doubt.
Right. Yeah, that's good. That's good. Okay, well, we just had 30 minutes of fun. Kent, we're good. So Professor Dave was 0 for 3. Kent, we'll have to do sometime soon, hopefully sooner rather than later. We'll go into the next 3 points and we'll show why Professor Dave is probably, I'm predicting, 0 for 6. So with that, let's bring in our first guest. And our first guest is Brian from the Apologetics 101 channel. Brian, great to have you here with us for this open mic debate and Q&A. So if you wanted to give a brief introduction to anybody who might be unfamiliar with you, and then feel free to ask Kent your question.
Sure. I'm Brian from Apologetics 101, and great to see you again, Kent.
Hey, good to see you.
I was wondering, what would you say? What would be your response if an evolutionist says evolution is a fact? How would you respond to that? Now, of course, they kind of equivocate. They go from what we agree with, which are variations within the kind that y'all been talking about, and they move to common descent with that. So how would you address that if someone told you evolution is a fact? Look at all these variations, like what Professor Dave said in that clip, and then they move to the descent with modification, which is the very issue we disagree with. So how would you respond to that?
I always respond by showing this chart. There are 6 different meanings to that word. When you say evolution is a fact, you're talking about microevolution, variations within the kind. There are now 339 recognized breeds of dogs. I agree. Does that prove dogs are related to whales? See, in their mind, it does. That's what they've been trained to think, and it's wrong. So again, they're trying to trick you. They say, well, evolution is a fact. Well, which one? Microevolution? Yep, that's a fact. Cosmic evolution? That's not a fact. None of the first 5 they're not part of science. They're not proven. They're not a fact. They're religion.
Yeah, you
so
know,
you say
Richard,
evolution is part of their work. Go ahead.
Richard Dawkins conceded that it could be the case that we were seeded here by aliens. And so if that's the case, then it could be possible that these aliens seeded life forms with similarities. And if that's the case, then it's possible that evolution didn't actually happen. So even on their own terms, evolution's not a fact. But they don't really have another option, do they?
And to say it came from outer space, all it does is kick the can down the road.
Yeah.
How did it get started out there?
Oh, by Darwinian means, of course.
Oh, yeah.
Did you have another question, brother?
Brian?
No, I was typing. Sorry. I had another question, but I can't really remember it now.
Okay.
You've debated Professor Day before, haven't you, Kent?
Oh, yeah. I'll do it again anytime. If they shut off his mic when it's my turn to talk and shut off my mic when it's his turn to talk. Equal time, no interrupting. Same with Lauren Rob.
I remember that. I think I might have did a review of that debate, actually. But I remember that he was really getting aggressive in that debate.
Oh, I don't mind aggression. Go for it. Bring it on.
All right.
Stop interrupting me.
Right.
All right.
All right.
Thank you,
yeah,
Brad.
that's pretty much all there. That's all the questions I got. Thanks, Donny.
All right. Thank you, Brian.
Brian, appreciate it. Keep up the good work on your channel, brother. Always a pleasure to have you. So feel free to stick around if you'd like to, or however you'd like to go from here. So Brian, thank you for the questions. Okay, now we've got Andrew C. Andrew C. and Kent have engaged several times in the past, so it's always fun. And you are our first, I guess, in person, you could say, evolutionist for tonight's open mic. And so, Andrew, why don't you give a brief intro into who you are, and then I guess we'll allow you and Kent to engage the topic of evolution for a little bit. Go ahead.
Yeah, sure. So my name's Andrew. I'm not a scientist by any means, but I am, I guess, curious about the natural world, its features, and I try to do as much research as I can. But I guess tonight I'm interested in Kent's thoughts about some of the evidence for evolution. I guess right off the bat, I'll go into what I want to talk about specifically, and then we can go on to other questions if one pops up or if someone else joins or whatnot.
Okay, that sounds good. What we'll do is, like we usually do in debates, we'll go one topic at a time, and we'll make sure that you both, Andrew and Kent, get equal time to respond. So therefore, Andrew, if you'd like to present your first point or your first argument, and then we will interact with it for a little bit. Go ahead.
Yeah. So the first topic I want to bring up tonight, Ken, are you familiar with the family of pseudogenes called, typically called nanog, that are shared between chimps and humans? Or let's just start. Are you familiar with the nanog pseudogene family, for starters? Let's just start there.
Well, I'm not an expert on it, but yes, the fact that we have similar genes, again, proves the same author wrote the code. That's all.
Well, I was talking about pseudogenes, and do you know what a pseudogene is specifically?
Well, pseudo false doesn't do anything that they know of yet. I don't think we completely understand the gene code to be able to say that's a pseudo gene. They used to say there's 53 different organs you don't need anymore. Used to regularly take out appendixes and tonsils and all kinds of things. Now they know there's a use for them. It was a matter of science catching up with what we needed. So I think maybe I'd be cautious of that term pseudogene and say that doesn't prove.
Yeah, fair enough. Yeah. So the nanog pseudogene family in particular. So kind of just some background here, so that we're both using the same information. There's the actual nanog gene on chromosome 12. That's in both humans and chimps. So obviously you would say that's a common designer there. And that's the functional gene. There's on the same chromosome 12, you have what's called a tandem duplication. So you have a pseudogene, or what we currently think is a pseudogene. There's some evidence that it may be partly functional or partly expressed, but that's still kind of iffy as far as I can tell at the moment. So there's one on chromosome 12. Now there are 9 other pseudogenes that are called process pseudogenes. And how it works is basically you have your DNA, right, that's getting transcribed into a messenger RNA. And there's some splicing going on there, some elements being picked and kind of spliced out. Basically, that's where the term alternative splicing comes from. And from there, you have what's called a mature mRNA. Now, sometimes that can be reverse transcribed back into DNA and inserted back into the genome. And that's how you get what's called a process pseudogene. And it turns out between chimps and humans on not just chromosome 12, but on pretty much a bunch of different chromosomes, 9 pseudogenes total in what seem to be random locations, and we share them between us and chimps at the same chromosome location. So how would you explain that? I guess let's start there.
And Kent, before you respond, just to reiterate a little bit, and so the audience can get it as well. Are you basically saying that we have these pseudogene families, these similar pseudogenes that you're saying are once protein coding genes are now broken through mutations or retrotransposition, depending on if you're looking at a process or non-process pseudogene. And because we share those in the same genetic locations or loci as the chimpanzees and other great apes, we must have inherited those mistakes over time through common descent. Is that basically the argument you're making, Andrew?
Yeah, pretty much. I can get in more detail if need be, but yeah, that's pretty much it.
Okay, well, we'll start there. We'll hand it over to Kent now. Kent, go ahead.
Well, if I found 50 soldiers after a battle that are all deaf in their right ear, I think maybe I would assume they all had a bomb go off on the right side and deafened them. They all went through the same event, caused the same problem. Could something have happened to cause the pseudogenes in that particular chromosome to be like it is? Could there be another explanation for it? Or are you convinced that's common ancestor? If you're already convinced it's a common, if you'd like to be related to the apes, that's your business, okay? But is that, in a court of law, would that hold up as proof that we are related?
Well, it's not just the disabling mutations that's at play here. We also have the insertion event itself. So these insertion events are random, like they're not necessarily going to happen, or the probability of them happening at the same loci on the chromosome is extremely remote. So there's that for starters, and then on top of that, like you said, you have the disabling mutations. Well, I'll just give one example. So in the retrotransposition event itself, right? So as it's being reverse transcribed from messenger RNA back into DNA, and then it's inserted. The promoter region typically isn't reverse transcribed with it, right? Because it's coming from RNA. It's not coming from the gene location that it originally came from. So in that case, it's no longer able to be transcribed from there. So it can't really be functional at that point, at least not in the same way as a protein coding gene is functional, even though it still looks like a protein coding gene. Does that make sense?
Yes, but I think giving way too much weight to this. That code you're talking about in the gene is so complex. To find a few similarities like this is, I bet I could look through books in my library. I found one on page 12. It said, "Let's go to town." Looked in a completely different random book, and it was on page 27. "Let's go to town." Wow, that proves nobody wrote those books. That's kind of the argument you're making. Because we find these same pseudogenes in these two different creatures, therefore there's no designer. That's completely illogical. It's much more logical to say they experienced a common event that caused this, or maybe we don't know what that pseudogene does yet. I think we need to admit our knowledge of the human gene code is still at kindergarten level compared to what it is. They don't know what a lot of those things do.
So,
They didn't
so
know
by
what the
common
appendix
event
was.
here, do you mean?
Actually, Andrew, before you continue, and
Okay.
I'm going to give you as much time as you want to respond to Kent's points and also my points. I just wanted to pull up a couple of references. And what Kent is saying here is exactly right. I mean, you go back 100 years and you would have all of these so-called vestigial organs and structures that are claimed to either have lost their original function or they're functionless, and now they have functions. But we see the same argument now applied to the genome. And so I've got just a few papers here. Notice pseudogene functionality. And so you can find dozens and dozens of papers on all kinds of so-called pseudogenes where they've actually discovered that rather than being the remnants of once functioning protein coding genes, they're actually necessary to sustain healthy life processes in the cell. And so if these so-called pseudogenes are not actually broken genes or genetic mistakes shared, and they're actually functional DNA units, then that makes sense from a common design perspective. And so if you'd like to respond to that, but I'd like to ask one clarifying question, Andrew. The
Sure.
pseudogene family that you're talking about, are you seeing similarities in that pseudogene family to the functioning protein coding family?
Yes.
They're healthy counterparts, basically?
Yes. That's how we can tell that it originally came from the functioning nano gene.
Right. And so, again, there's at least 2 or 3 papers that I'm aware of that answers this question: why do pseudogenes look like their so-called healthy counterparts? And the thing is, the pseudogene expression, it actually helps to regulate the translation of its protein coding counterpart. And so you have the protein coding version of this family, and then you have the non-protein coding version of it as well. And so what it does is the long non-coding RNAs produced, they enter various transcription networks. And so we have this elegant system where you have the non-protein coding versions regulating the protein coding versions, and they require those similarities to have that team effort going on, basically, you could say. And so to support Kent's argument that we might not know the function of a lot of these pseudogenes, that is true, and we're actually finding more and more functions for them. So Andrew, feel free to respond to what Kent has said and also to what I have said.
Yeah, so 2 points on what you said specifically, and then me and Ken can go back and forth from there. So first off, I find it odd, let's just say that you would have this designer, and okay, you might have them put those pseudogenes in a particular place, but make it look as if it did come from a mature mRNA product that was then inserted, but you also have 9 of them total. Like, why do you have 9 of them? Like, why not just 1? Why not just 2? Like, why this many, and why are they shared in these specific locations? So that's my first question. And then what was that? What else was I going to say?
If you'd like, we could start with that and hand it back to Kent.
Sure.
We'll
Yeah,
start with that.
it'll come back to me eventually.
Okay, yeah, one question at a time. There's 9 of them. How many genes are there when you compare these creatures that are not similar? If there are 9 that are similar, there must be 12 billion that are not similar, because the gene code has got a whole lot of code in there. I would point out there's probably a section of your genetic code someplace that tells your hair to keep growing on your head and on your beard, but not on your arm. Is there a gene code that tells the hair grow a certain length and stop. Do you think the monkeys have the same gene code? Why does their beard not keep growing? Ours does, theirs doesn't. I bet there's gene code for quite a bit of code to cause hair to grow, to be the protein arranged the way it is. And many of them, you look at them under the microscope and just the hair is complicated. Plus the follicle, what if a hair is pulled out, grows a new one? Why doesn't it keep growing new ones all over the palm of your hands? Why only your arm? Why not your palm? Why not inside your mouth? I bet there's gene code for all of this. And the fact that there are similarities to not have hair grow in your mouth, and the monkeys probably don't have a gene to grow hair in their mouth either. Does that prove we're related? No, you don't want hair growing in your mouth. It's a common designer.
Well, you have to remember, Kent, that the gene code, as you're putting it here, isn't just about the genes themselves. It's also about the regulatory networks that connect them and control their expression in different places in the body at different times and whatnot. So that kind of addresses the hair example you provided there.
Hang on, let me respond here. I think that the fact that we have some similarities could just as easily be a common designer, or we've gone through a common trauma, or just our level of understanding is kindergarten level of all of this. They didn't know there were genes until a couple hundred years ago.
Well, all right, but that kind of gets to the other thing I want to ask, which is what do you mean by common event or common trauma here? Like, is it the insertion event itself? Is it the mutations that disabled this gene? Like, what exactly are you saying here?
Well, I don't know. We'd have to look, but we can't go back in history. But could they? The fact that it's a pseudogene, a gene that's not working anymore, how's that going to help evolution? You need new features added. How would that turn an amoeba to a whale or a human?
Right, but we're talking about common descent here, not that particular argument.
That is common descent. They got charts here with amoeba connected to the whale. Whales,
right, but I'm saying, like, why are they shared according to this common event idea? Like, what's the event that's causing them to be shared?
Well, I think Kent has answered that if they are shared, okay, a lot of these pseudogenes could have a function and therefore they're not genetic mistakes, or they used to be protein coding genes and then they're hit with mutations and became broken. And so you're saying they inherited that broken gene from a common ancestor with the chimpanzee. But Kent's pointing out that might not be the case. They might have unknown functions. Also, mutations are not random. We understand that a lot of mutations are non-random events, and there's at least a few papers suggesting that as well. And so you could have similar mutations in similar spots due to environment or similar trauma, as Kent has pointed out.
You might have more mutations in certain spots, but they're still probabilistic in nature. You're not going to have the exact same set of mutations in the exact same spot just due to chance.
Well, no, that's assuming that your ratio of non-random mutations to random mutations leans more towards them still being random.
There's no such thing as a non-random mutation. I don't know what you mean by that.
A lot of spots in the genome are designed to be hit with mutations. Is
right.
The point.
They're mutational hotspots. A lot of mutations happen there, but they still happen there in a probabilistic way. They're not happening A, B, C, D in a particular order. That's not the same thing.
That's assuming that there is less mutational hotspots than there actually are, because there's discovering that there's a lot more mutational hotspots than evolutionists have assumed. I just want to say this one point. I would argue that the pseudogenes that you're talking about, they have functions. For example, your non-protein coding pseudogenes, I've pointed out how they help to regulate their so-called healthy counterpart. And so there is a network there of genomic function. But another thing is the RNA that's actually produced by the pseudogene. So yes, a protein is not produced, but RNA is produced by the pseudogene, and that RNA can actually act as a decoy. Are you familiar with the decoy function that they've discovered, Andrew?
Yes, that can be for some pseudogenes, but not the ones I'm referring to specifically here.
I would argue that it is the case for this, because you have the so-called broken. Well, let me just finish. You have the so-called broken version of this protein coding gene, but we're discovering that the RNA produced from that so-called pseudogene, it can act as a decoy for things that might target the protein coding counterpart. And so it's basically being hit with those mutations rather than the protein coding counterpart. And so that would increase the protein coding version. It would increase its lifespan and the amount of translation into proteins. And so it's a function. And so Kent has provided 2 answers. Kent, if there's anything else you'd like to add.
Well, if I can say one more thing there,
go ahead.
real quick. So that would apply if it could produce RNA in the first place. But what I'm saying for the nanog pseudogenes I brought up in particular, because they come from processed mRNA transcripts, they don't contain promoter regions. They can't be transcribed, so they can't produce RNA. So the functional role you're talking about there wouldn't apply to these shared pseudogenes specifically.
Well, I'll say this, and then I want to hand it back to Kent too, is it's the same thing with endogenous retroviruses. And so we have what's called transcriptionally silent endogenous retroviruses, and we also have transcriptionally silent pseudogenes. And in terms of the endogenous retroviruses, they can actually provide, and I've got one paper that demonstrate this, they can provide a selection advantage to the host because these quote unquote transcriptionally silent pseudogenes that don't produce an RNA, they can promote recombination. And that actually increases the amount of genetic variation in the specific host that can be passed on to the next generation. And so even in that instance that you're referring to, it can still have a function. And so again, if these pseudogenes or these endogenous retroviruses, even the transcriptionally silent ones, if they have a function, then the reason why they're shared between various species is for common design reasons and not common ancestry.
Why did they look like the original protein coding gene then, if they don't produce proteins or RNA?
Well, I mean, I could answer that, but I do want to make sure that Kent gets his response on the pseudogene point. Kent, go ahead, brother.
No, go ahead. I think we've given enough. I think, again, we're all dealing with kindergarten level knowledge of what these things really do, and keep doing more research. So far, you're jumping at anything to support your evolution theory. I'm curious about the bigger picture. Are you wanting to believe you're related to an ape for some reason, or are you willing to listen?
What I want or not is kind of irrelevant here, Ken. It's what the evidence suggests.
Oh, no, there's a motive why people choose certain bits of evidence to look for. There's a motive. Are you running from God for some reason, or if I could prove to you there was a God and he made the world, would you accept that? Would you believe him, or are you going to keep going looking for more evidence for your evolution?
Some pretty extraordinary evidence for that extraordinary claim you're bringing up.
You're bringing a claim that everybody's related to a mosquito and came from an amoeba. If you believe in evolution,
evidence for it.
You talk about an extraordinary claim.
Look at
Hey, Andrew, we're going to let Kent talk without interrupting.
Okay. You talk about extraordinary claim. They tell the kids that the humans, the birds, and the pine trees all came from an amoeba. That's an extraordinary claim. Nobody's ever seen a pine tree produce a non-pine tree. Man has divided them into 115 different kinds of pine trees. Now they're still a pine tree. All anybody's ever seen is pine trees make pine cones and pine tree babies. Do you believe you are related to a pine tree, Andrew?
Yes.
Okay, I'll add you to my chart. Andrew,
so
related to a pine tree.
So let me ask a question in turn then. For someone actually brought this up in side chat, and I would like to honor their request and ask this question. So Ken, do you know what those lines on that chart represent, since you keep bringing up lines on paper so much?
I do indeed. They represent a wild imagination from somebody who was drunk or on drugs.
On the chart specifically, what do they represent, like scientifically? I know you have your opinion about it, but what do they represent according to evolution?
They have I'll show you. This is the charts they feed to the kids all the time. Here we have humans. We get a simpler one here. They have the protozoa turning into all these other creatures. This isn't science. This isn't scientific research. I know what the chart
shows, but what do the connections specifically, or what are they representing according to people who already accept evolution?
Oh, they can believe whatever they want. I'm telling you, asked me what I think they do. I think they represent wild imagination from an alcoholic or a drug
so
addict.
you don't like these charts, but you also don't know what they represent.
That line is supposed to represent that some kind of descent. Here they're showing the
There we
protozoa.
go.
I understand. It doesn't. That's not science. Nobody's ever seen a protozoa produce a non-protozoa. Why would we draw a line from a protozoa to a turtle? You don't know that science. That's religion. That's all I keep pointing out. You guys can believe whatever you want to believe. None of these charts represent science at all. Has anybody ever seen a protozoa or a bacteria produce anything other than the same kind? Do you have evidence that a protozoa turned to a human?
Birthing another, no, because evolution is a population phenomenon.
Nobody's ever seen a population of cows produce a population of non-cows either. My neighbors have a whole herd of cows.
So you're saying populations don't evolve?
No, they stay the
Populations
same
don't change
kind.
over time?
My neighbors have a whole herd of cows. They always make baby cows over there, every time. Do you believe
That's
cows
not what
are
I
related
asked,
to
though.
came from a
Are you
protozoa?
saying populations don't evolve? They don't change? Populations don't change?
There's that word evolution again. That's the slippery word. Of course, there are variations within the kind. If we turned all the dogs in the world loose in Alaska and come back and visit in 10 years, probably only the wolf or that type of body style, long, thick hair, would survive. I agree. But if you turned all those loose in the desert, none of them would survive. Now only the dingo body style survives. Thin hair, thin body, because they can get rid of the heat better. Long legs, get away.
So
that's not, I'm answering your question. You don't like my answer. No, evolution does not happen. Dogs make baby dogs every time. You're confusing this word evolution. Evolution, a variation within the same kind, producing 300 breeds of dogs.
Populations change. You would agree with they change at least, right?
There you are, slippery definition again. The word change, the
it's
definition
a simple
of
yes
evolution.
or no question.
No, I'm answering it. Variations, I've answered this for 25 years this way. Variations within the kind, number 6, that one has been observed, that one happens. If you want to draw lines on paper from the Chihuahua to the Great Dane and trace how the dogs have branched off into a dog family tree, I would agree. I think that'd be a good field of research. But you guys go absolutely start raving lunatic and think the dogs are related to mosquitoes because you can connect the Chihuahua and the Great Dane. That's not science.
Still haven't answered my question.
Hey,
I'm
Andrew.
answering your question. The lines on paper are supposed to represent something we can demonstrate as common ancestry. I think I could draw a line on paper between me and my dad, and between my dad and my grandpa.
Specifically.
Andrew, do you have another
question? Andrew, you're just plain not getting it. I think everybody with half a brain cell functioning tonight is seeing.
Okay. How about this question? I'll ask another one.
Well, I'm just going to jump in real quick, Andrew. So what we've discussed now is pseudogenes, so we can leave that up to the audience. We had some good discussion on that, and then we talked about the lines within the phylogenetic trees. And so why don't we now allow you to bring up a third point or topic to interact with for a bit before we get to the next guest. Andrew, go ahead.
Yeah, so populations specifically, you keep saying, okay, kinds produce kinds. Okay, I get your shtick there. But what exactly is the mechanistic limit to those populations continuing to change over time? Like, I know you're going to say, oh, well, a squirrel will always stay a squirrel, but like, what's the mechanism there that's preventing that variation, those differences from accumulating over time? You haven't really given one.
Well, the DNA code. I don't think you're ever going to crossbreed squirrels and end up with wings on it. There's nothing in the DNA code for a squirrel to make wings.
Well, that's what I mean. You're giving an example, but you're not giving a limit.
Andrew, you asked me what the limit is. I think observation of all the farmers in the history of the world would tell us there is some kind of limit. Do you think there's a limit on dog size? Do you think they'll ever get a dog as big as the moon, Andrew?
I mean, physics would dictate not.
Okay, so there's a physical limit. Do you think there's a DNA limit? Do you think there's a genetic limit? There seems to be a limit. You don't think there's a limit.
What's the limit?
You guys want me to pay to have all the kids learn that the amoeba turned to a biology teacher. There are limits. The amoeba only produces baby amoebas. That's all. And would you please shut
Andrew,
his mic off?
if you're gonna keep interrupting, we're just gonna move on.
Okay.
Yeah,
Okay.
move on or shut him up when it's my turn to talk, okay? It's real simple. There's obviously a limit that we've observed for all of history. Amoeba only make baby amoeba. Why do they have the amoeba with the line going up to a biology teacher? This isn't science. It's science to say the amoeba produce amoeba. That can be done in the laboratory. They've done it for generations. You get a new generation of bacteria every 8 hours. So one scientist in 40 years can watch billions, thousands, millions maybe, of generations. They don't ever see it produce anything but a bacteria. Why would we draw a line on paper connecting a bacteria to a turtle and a frog and a bird? This is pure imagination by a drunk. Tell him I said so. Okay, go ahead, Andrew.
So
Well, before you
would
do, Andrew, I just would like to ask you: Do you, Andrew, do creationists believe that populations change? Do we believe
I
that?
would assume so, based on what AIG and CMI have said, for example.
And why were you asking Kent that same question?
Well, I was trying to demonstrate a point.
What was the point that you were trying to straw man us when you actually know what we believe?
No, that wasn't my point. I was leading up to the
That's the
question
only
you just
point that
asked,
was-
actually.
But go ahead.
Yeah, so I was leading up to this question about where exactly the limit is, because you said, okay, there's a limit in the DNA. Okay, that's a claim, but you haven't really supported that claim. You've just provided examples. You said, obviously, this is the case. Well, I'm not going to take your word for it. Where's the limit in the DNA here, in the genetics specifically? A genetic mechanism, let's put it that way.
Is there a law of monophyletum, Kent?
Well, as far as supporting a
That's what I
claim,
asked.
he is trying to shift the burden of proof, okay? The Bible says the animals will bring forth after their kind. That's all we've ever observed. But I'm not asking for everybody to pay for the Bible to be taught in schools. You guys are demanding that everybody pay for your religion to be taught in schools that says horses are related to bananas. They got a line on paper connecting them. Burden of proof's on you. So support the claim. I've been asking that for decades. Support
I
the
don't
claim.
really think so, because you originally said there is a limit. So I'm asking you to support that specific claim.
I don't need to support the claim. I'm making a claim. I'm not asking everybody to pay for it. I believe it's obvious.
That's not how the burden of proof works, Ken.
Donny, shut him off when it's my turn to talk. Please, shut him off. Okay?
Can't go ahead.
I made the claim that nobody's ever seen a cow produce a non-cow or a dog produce a non-dog. That is a claim. That's all. I think. Show me an example where that happened otherwise than that. Show me any dog breeder that ever said, "Wow, I got something non-dog out of this mating just did." It doesn't happen. You can imagine it. So I think the limit would come from observation of history. I think the limit would come. There are obviously some physical limits. You're never going to get a dog as big as the moon or as small as a bacteria. We see some. I think there's a DNA limiting. DNA's limiting it. You're not going to add any new information. But you guys want to take this amoeba and add arms, eyes, legs, hair, skin. You're going to add all kinds of things that amoeba don't have. But you put them on a chart in paper and call it science and make the kids learn this. And it's nothing but propaganda. This isn't science. That's all I've been saying. You can draw all the lines on paper you want. You think a protozoa turned to a frog? I'd like to support that claim. Show me any protozoa turning to anything other than a protozoa, let alone into a frog. I mean, a frog's got a skeletal system, reproductive system, digestive system, integumentary system, a circulatory system. Show me this happening. It isn't science. I don't know how you guys can't see it. I don't know how you can't admit it. I don't know how you can believe it. It's dumb. Capital D, dumb. Go ahead.
Andrew,
Well,
go ahead.
Before you do, Andrew, Matt, do you have any thoughts on this?
Oh yeah, one of my favorite subjects. I made a video called Genetic Boundaries a long time ago, and I like to point out when we're looking at ancestry, we look at the mitochondria and we look at the Y chromosome because they don't repair themselves. As where when you look at these evolutionary trees of life and you connect those different things, of course there's genetic similarity, but why? It's because they're looking at the protein coding regions or the nuclear DNA, and since those repair themselves, they're not very good indicators of connecting ancestry. That's why when you follow the Y chromosome back in time, it lands on a common ancestor of a human. Or when you follow it backwards with a dog, it lands on a wolf. It doesn't land on the common ancestor of the bear and the wolf, what evolution needs. It doesn't land on these common ancestors that are supposed to be diverging into these other family families and things that evolution is talking about. So I say the genetic mechanisms that we're looking at with diversity come from gene conversion and recombination, as where evolution is looking at beneficial mutations over deep, vast amounts of time. So we're looking at changes through a different lens. That's all. You guys need a lot of time because you need the time for the beneficial mutations to do everything. And you're looking at the relation from the protein coding regions, which is nuclear DNA. We're looking at it from the observable evidence, like a paternity test, like how can we prove who's related? So we look at that and we trace it back and we look at those regions because they can't repair themselves. So we look at it more of like a direct line and we don't have the inference. When you look at the nuclear DNA, that's how you build those evolutionary trees of life. So we have a different perspective when we're looking at these things.
Okay, and Matt, thank you. And to be fair, Andrew, feel free to respond to whatever you'd like to from Kent and also from Matt. And then we'll hand it back to Kent and Matt if he wanted to respond too. So Andrew, the floor is yours.
Yeah, so I just think that's a false dichotomy coming from Matt there, because it's not really one or the other in terms of evolution and creation. It can be all of them at the same time, I would think. But it seems like me and Kent are kind of hitting a brick wall here. So I'll ask a different topic, if that's okay. Since kind of Matt brought up proteins specifically, I guess I'll bring up this question of ubiquitous proteins, which I'm hoping everyone's familiar with what that means exactly. Basically, a protein or a protein family between different organisms, usually very distantly related. So bats, birds, simple-celled eukaryotes, things like that. Just a broad swath of the tree of life, and they basically do similar functions. So my question is, okay, you would say that that's due to common design because they share these similar proteins for similar functions. But within the amino acid coding sequence, they have what are called synonymous mutations that are shared in this nested hierarchical pattern that you guys were talking about earlier, that don't affect the protein's function because they don't change the amino acid sequence in any way. So I guess my question is, in this broad swath of the tree of life where these ubiquitous proteins for similar functions are shared, why do they also share this specific pattern of silent mutations, basically?
This is similar to your last line of questioning. You're still dealing with something we know so little about. Donny, you're much more up to speed on the latest on this. I keep my research in other areas, but so what? If there are some similarities of proteins, same designer wrote the code. I could go through my books in the library and find, wow, this one's got the letter A and D in a series. Look at that, 3 letters in a row, A and D. I could find it in another book too, A and D. And you're assuming nobody wrote the book because of that. I think our knowledge of this is kindergarten level compared to what it needs to be, and the code is way more complex. I think I could find Microsoft Word programs. If I could examine the lines of code, I could find thousands of similarities between that and Microsoft PowerPoint. What does that prove? They both evolved from Morse code? No. The same guys wrote the code. It's a complex code, and they reuse the same lines of code sometimes. I bet spell check in PowerPoint is the same dictionary that spell check in Word is. What does that prove? It proves a common designer. That's what I'm trying to get to you. You're not getting it. Donny, you're better at this than me. So tell them about this. Is ubiquitous
right.
protein
If
stuff.
I could just quickly respond to that. So but designers with computer codes, why would they use similar lines of code that don't ultimately affect the program? If we're to use that analogy here, that's not exactly what they would use and reuse here. They'd use the functional parts, and obviously you're saying the protein aspect of it because they're shared proteins, and then that's common design. Sure, I admitted that you'd say that, but I'm talking about a deeper aspect of it here, which is the synonymous mutations.
Well, and Kent did answer that. He said, again, it goes back to the same line of questioning he did earlier with the pseudogenes, as in they may have known functional roles, they may have impacts on the cell. And it turns out with your so-called synonymous mutations, where you got non-synonymous and synonymous, your synonymous mutation is a change in the DNA sequence that codes for amino acids in a protein sequence, but does not change the encoded amino acid. And so an example of this is your third position codon variation, right, in coding for a protein. And so there's at least one paper that I could cite and screen share over where they talk about the multifunctionality, the multifunctional nature of third position codon variation, where it's not just there to tolerate error. It actually has a greater impact on the cell, Andrew, where these synonymous mutations, quote unquote, they actually act and function in information flow, in determining how fast and how slow the cell produces these elements, essentially. So your question is assuming that there's not a greater impact within these proteins. And so it does turn out that there is indeed a greater impact to these so-called synonymous mutations.
Well, and Donny, if I could add, we are probably losing 99% of the audience right here because he wants to harp on one little minor point that no human on the planet completely understands what all these proteins do. And he's certainly wasting my time. I'd rather have him debate somebody who's more expert on this topic than me. But I would say this isn't evidence for a common relationship. You can believe that if you want. I choose to believe the same guy wrote the code. So move on to a new topic. Go believe what you want. But I think we're losing all the audience by hammering on this one, giving this guy all this time.
Right. So, Andrew, I do appreciate it. We've talked about pseudogenes. I think we've talked about it for a good amount of time. We've talked about the lines within the phylogenetic trees. We've also discussed synonymous mutations and nested hierarchies. And so, admittedly, these are very technical topics. And so I think we will now move on to the next person, as we are going on about an hour and 18 minutes. So, Andrew, I hope you do feel that you've had a fair amount of time to engage these technical topics. And if you want, stick around, Andrew. And as we work our way around, we could possibly have you bring up a fourth or fifth topic.
Yeah.
And so,
I got some stuff I need to take care of probably, but I'll see if this thing is still running in a little bit. Maybe I'll join again. But I appreciate your time, Kent. We'll probably run into each other another time. But all right, have a good one, Hen.
Okay, Andrew, thank you. Thank you for joining. Okay, I'm going to bring in a couple people right now. So I got somebody named Nunya Biz, who I think goes by Mike. And I'm also going to bring in Brock Council. Okay, so Brock, good to have you as well. I'm going to bring in Hank. Hank, good to have you. And I'll bring in Alec Cox. Good to have you, brother. So, all right, let's go around the room and we'll do a couple minutes per person. And I'm assuming that this is going to be more of a Q. I think this is going to be more of a Q&A time rather than a debate like we just had with Andrew. So let's start with Mike. Mike, you were next on the panel. And so briefly introduce yourself and then ask Kent your question.
Donny Gent, thank you for the introduction. The time I'm a polytheist. I believe God the Father of Genesis 1:1 and speaking no words yet, creating the formless and void earth, courted the spirit, Ruach HaKodesh of Genesis 1:2, and had little baby Jesus light of Genesis 1:3. My question to Kent, the science gent, I love this brother. He is genius. Humans beget humans. I have to get to work, Donnie. I'm sorry to jump in like this. Amoebas beget amoebas. It even takes 8 hours. Chimpanzees beget chimpanzees. Why would you try to convince an evolutionist of these things and then have them turn to your God who begat a son in Psalm 2? He's getting married in Psalm 45, and he's seated at the right hand of the Father, waiting till his enemies are made his footstool in Psalm 110. Why is there no interval? There is a 9-month interval for humans, and you even said an 8-hour interval for amoebas to beget amoebas. Why does your Father and the Son, when he begets them, it's instantaneous, it's always? Thank you, Donnie.
Well, I don't know. I guess my God can do whatever he wishes. He can take a nothing and produce everything from it. My God can speak things into existence. I can't do that. So I worship a God that's completely outside of time, space, and matter. He's not limited by those things. Humans make a baby, takes 9 months. You're right. Bacteria make one, takes 8 hours. Different pregnancy, different gestation time for lots of different plants and animals. I cover that on my Friday night program on drdino.com. I mean, on Genesis Baptist Church channel on YouTube, making babies. None of the atheists have answered any of my questions I've asked for 27 consecutive programs now. How did this evolve to make babies? So God has chosen to reveal himself to us as a father and a son. I don't understand the whole Trinity, but again, I'm not asking for all the Bible stuff to be taught at taxpayer expense. I think you're trying to shift the burden of proof. The question tonight is, where's the evidence for evolution? It doesn't matter what the Bible says. It doesn't matter what God said. I mean, for this debate, there is no evidence of any animal or plant ever producing anything other than its same kind. Cows make cows, dogs make dogs. So as far as the Bible and all the different 33,101 verses, and you want to pick at each one, go ahead, but that's not the topic of the debate tonight. Where is the evidence for evolution is what I'd like to see. I think, Donny, isn't that the purpose of this debate?
Absolutely. Absolutely. Is there evidence for evolution, Q&A, and debate? So, Mike, I hope you're satisfied with the answer. I do appreciate the question. We're now going to move on to Brock Counsel. And so, Brock, I think this is your first time here in an open mic, and therefore feel free to give a brief intro into who you are. Also, state your position, whether you're creationist, evolutionist, and then ask Kent your question.
I got a question. Can you hear me?
Yes. Yeah.
Yep.
Okay. My name is Brock John Counsel. I don't know if y'all knew that, my middle name. I became an atheist around 2018. And I kind of believed to some degree of evolution, but I didn't know all of it. I knew I didn't, so I was like, maybe I would be wrong, and I kind of just came to question it later. So my main problem with evolution is how we name animals. First off, species, like people will say like a kind in the Bible, oh, that's vague. And it might be, but species is also, I think, a little vague, maybe. Like, I don't think we've got a good definition. Like, there's multiple ones, and I think even Erica from Guts It Given even said it was not like defined well. There's many different ones. So, and according to Darwin's theory of evolution, like I would be an ape because my ancestors were apes. Which, if you want to define it that way, that's fine. Until we discover so many animals, and like we just run out of names. I told my sister's ex-boyfriend about this, and he said we'd invent new names. And I was like, really? What do you think, Ken Tovin, Dr. Kent? Do you think that makes sense? Like, we run out of names?
I don't think, no, we're not going to run out of names. I don't think the animals care at all what we call them. Not in the least. I think when the cows get ready to make babies, they look for another cow, without exception. You're right. The word species is kind of a nebulous word. I can't get my thing to go into the right mode here.
I really want to know what a species is.
Well, there's about, I don't know how many different definitions of species, quite a few different definitions of that word species.
I think I saw 5, maybe. Like a little more than 5.
It doesn't,
wow.
Again, how we classify them does not matter at all to the plants or animals. This is purely man trying to put our classification system on them. Turn them loose. They know what their kind is. Okay? There are, I think, 37 varieties of foxes. They might be infertile. Man has decided to divide them up into 37 species. I think the foxes don't care how we divide them up. So I think the word species is a slippery term. And I apologize, I've never had my PowerPoint lock up like this before. But I'll resume slideshow, it's asking me.
Also, do you remember that I called you? You remember that?
I get a million calls a day. I'd never remember that. But go.
I could have sworn you agreed with me on the naming. I thought you agreed we'd run out of names. You know what I mean?
Yeah, sorry, I get so many calls. That's why my daughter's wedding's been played 50 times on America's Funniest Home Videos. Type in Kent Hoven's daughter's wedding. I'm sorry. But Andrew, I'm glad you called in. And let's see, let me shut this one down. Oh, there it is. Okay, home. Good. Okay. Species, finally, there we go. Definition of species. Group of organisms consisting of similar individuals capable of exchanging genes. Look at they have down below this here. Type, kind, sort. Why would the dictionary say a species is like the same kind? A kind or sort. Wow. Type, kind, sort, genus, family, order. Again, I don't care. I don't think the animals care how we classify them. God said they'll bring forth after their kind, after their kind, after their kind. I mean, it's in the Bible a whole bunch of times. That's all we've ever seen. There are 10 varieties of birds, like bigger than a crow. Okay, they're still a bird. They bring forth after their kind. The heron, I think there are 47 species of herons. Is it right here? 72. 72 species of herons. Some guy decided, let's divide them up in 72 species. The herons do not care how we divide them up. Don't care at all. They're still bringing forth after their sort, after their kind. So I think it's silly to argue over what exactly is a species, what exactly is a kind. Let the animals sort it out. They're smarter than the scientists. Turn them loose. They know what they want.
I'm pretty sure you're right about the animals not caring at all what we name them. They don't care. They're just animals. But I could have sworn if we named them a certain way, it would help us understand them better. But I don't think we're doing it right now. Like, we're not doing it correctly because.
Well, they're constantly having to move animals or plants from one group to another. Say, oh, that really doesn't belong here. Let's shift them around. And somebody gets a PhD for writing a paper on why we should classify this one over here and not over here. Again, the plants and animals don't care. We're wasting a whole lot of time on this, I think.
And there's something else. Dang it.
Okay, Brock. I appreciate your questions. Sam, was there anything you wanted to add? I thought you said there's something you wanted to say to that. Or was that
well, no, I was going to just point out that Mike had made a categorical error by putting the creator in the same category as the creation. So,
good point.
Yeah. When we acknowledge his error, then his question doesn't really stand. I can't
say that again.
Right. God can do what he wants because he's the creator.
Right.
And we can say we know this because God has revealed it to us. Yeah.
Do you think that's a good role model to have a single daddy that never had an interval of time between him and his son?
Well, my opinion doesn't really matter, does it?
When you're trying to put your human limitations on God.
He created Adam instantly.
I guess I don't understand even the purpose of that question. What's he trying to get to? Okay, let's suppose he could come up with questions and prove the Bible's wrong. That still doesn't help evolution. Tonight's debate is, where is the evidence for evolution? Forget the Bible. Forget God. Where's the evidence for evolution? You guys want me to believe that you're related, everybody's related to a pine tree. Where's the evidence for that? Stay on topic.
Brock, is there a line of evidence you'd like to present? I saw.
As I've said, I'm a little skeptical of evolution. I think the process happens where there's like different groups splitting off into different groups, but it probably has limits, like Kent said, and that doesn't mean we came from an ape. You know what I mean? Like, do we really know that? Probably not. Maybe we evolved from something else, or maybe not. But even if we were created by God, we do seem to speciate a little. That's what we got, different colors of skin, different heights, which is little differences that can build up. You know what I mean? But that doesn't mean we came from a Australopithecus, I guess.
I would say at some point, it could be that the word kind equals a species with some kinds of animals. In some cases, it might be the family. It might be the genus. Again, I don't think the animals care.
They don't.
They know what their kind is. And it's futile. Again, we're trying to pick a Bible definition kind and trying to say, I don't like that word kind. Okay, forget the Bible. Where's the evidence for evolution? Stay on topic. There is none.
Did I go off topic?
No, you're doing fine. I'm just telling the rest of the people.
I'm nervous.
Nobody ever sees a dog produce what a 4-year-old would consider a non-dog. They want me to believe dogs came from a protozoa. I don't believe that.
We probably didn't come from protozoa.
So I'm gonna.
Hold it, Brock. Why do we put this in the textbooks then? Why do kids have to learn this propaganda?
I'm not the biggest expert on evolution, but maybe maybe the scientists just thought it was true and put it in there. Maybe they are lying. I don't know. Maybe they just want to get a paycheck. I want to know.
I'm going to throw this in here, Kent, as a line of evidence. So in the chat, we have Dr. Joel Duff. He's written, if I'm not mistaken, for BioLogos. And I've seen at least one of his videos where he, and Joel is in the chat, so correct me if I'm wrong, he has stated that whale evolution is just an undeniable line of evidence for common ancestry. And typically evolutionists, Ken, as you know, they'll point to the so-called vestigial pelvis that we find in whales today, and they will use that as at least one line of supporting evidence to say that whales have ultimately evolved from land-dwelling mammals. What's a good response to that, brother?
Well, this has been taught for a long time in people with very limited scientific knowledge about whale anatomy. They point to these bones in the whales. They call it the whale's pelvis. The textbooks do this all the time. Modern whales have hind limbs which have been reduced to a few tiny internal bones. Just imagine whales walking around. It's true. This is what's taught to the kids. This is what the bones they're talking about right there. These bones right there. They could say it's a whale's pelvis. No. Whales are pretty big. They have to mate in the water, underwater, in the dark, with no arms and no legs. They can't talk and say, "Scoot over, honey." This purpose of these bones is to be able to get the whales to make baby whales. They have muscles that attach to them that let them maneuver their penis around to make a baby whale. This is a lie to the kids. Those are not vestigial pelvis. They keep teaching this stuff. It's pure baloney, propaganda. I cover this on my video number 4, Lies in the Textbooks. I mean, the whale's penis might be 15 feet long, and he's got to move that thing around in the dark underwater without being able to talk. And so this is just, it's silly. They say the same thing about the snake. They say it's got vestigial hind leg. No, it doesn't. It's got little claws that allow it to mate. It's got nothing to do with walking on land. So they should stop lying to the kids. There's no evidence from whales for evolution. I'll debate the whole crew on BioLogos about that one.
There we go. The challenge is out there to BioLogos. Time to step up and bring forth your best evidence for evolution. Okay, so next on the panel is Hank. So Hank, I believe this is also your first time joining an open mic here on Standing for Truth. And so brief introduction into who you are, and then also what your position is, creationist or evolutionist, and then ask Kent your question.
Yes, so I'm a current polytheist, former atheist, and I worked in software development and logistics. So what I want to do is propose a scientific test that will disprove evolution categorically from biblical proportions. So all we need to do, we need Ken Ham's help. We need to gather every kind of animal and put them in the Ark Encounter, a real life size Noah's Ark replica. We need to keep them in the replica for a whole quarter instead of just 40 days because people be skeptical. Maybe it was just half-life thing. If we have them live out a whole quarter in the Ark, we categorically proved that we can have every kind of animal in the Ark and they'll live all the way through. But
I just want to make sure there's a question in there, Hank.
Yeah. So the question is, why aren't you doing that? Why aren't you doing that instead of debating all the evolutions about genes and stuff? We can just go ahead, shut them up, and then decide to deal with it. Deal with the power of God and accept that truth as you present it.
Any thoughts on that?
Thank you, Hank. I think it would take a whole lot more than that to shut some of them up, okay? They like their religion of evolution. It gives them freedom from God. That's what they really like about it. Putting all the animals, first of all, the rain was 40 days. Noah was in the ark for over a year. And there were no cages in the ark. All the animals were friendly. Let them wander around. Put out piles of food, they'll find it, Go back to their room at night when they want to go to sleep. So I think we'd end up with, there's a website called baraminology.com. Baramin is the Hebrew word for kind. How many kinds of animals? I think baraminology people have decided there's probably about 8,000 kinds of animals that needed to go on the ark. Fish didn't have to go on there. They had plenty of water outside. Okay. Insects didn't have to go on there. They survive fine on floating debris and floating log mats. So probably if you take the air-breathing, land-dwelling mammals, you could probably get by with 8,000 basic pairs of animals on this ark. After the flood, they've now produced thousands and thousands of variations. Maybe the dog and the wolf had a common ancestor. I wouldn't argue with that. It doesn't prove the dog and the sparrow have a common ancestor, which is what they believe. So yeah, we can do that. Nature does this same experiment you're talking about, Hank, every day. They're all loose in the woods right now. They know which ones to pick. Our squirrels look for other squirrels. They don't care at all about my wife's pug, dog. Never tried to mate with them one time. Our cows don't care about the horses. They look for another cow. They know they're smarter than most of the scientists, because some of these people will draw a line on paper between a horse and a cow. Oh, they're related. Come see our cows. They don't care about the horse at all. Not at all.
Hey, Kent, let me do a follow-up question on that. Let's just roll with Hank's idea. Would we expect, if we were to do an experiment like that today, would we expect the same results, considering that it's been thousands of years and these animals have been losing and degrading since the flood?
I think it might be hard to go back and pick out what the original two were in some cases, because there's been so much genetic load introduced and so many mutations have been introduced that it might be difficult to determine. It'd still be a fun experiment to try, but that's what every farmer does. Try to get a particular breed for their particular soil type, or their, what are they trying to accomplish? Google the world's record for milk production. Somebody sent me that. I couldn't believe it. One cow, 185 pounds a day. Now, the cow can barely walk. It would not survive in the woods. You got to bring the food to it and shovel the poop away. It can't survive on its own. But as long as you keep bringing it food, it'll keep producing milk. 185 pounds a day. Utterly ridiculous. And so, but that's probably getting close to the limit. There's a rodeo in Texas where they ride cows and jump them over fences. I've got a video of a cow jumping over a 6-foot fence. So I've got a theory. If we give that cow vitamins and make it to the gym to work out, someday it could jump over the moon. How's that for a theory? This is what the atheists absolutely do not get. They've gone stark raving stupid. They think because a cow can jump 6 feet, therefore, eventually, over millions of years, it could jump over the moon. They refuse to admit there seems to be a lot of different limits. Genetic limits, biological limits, muscular limits, skeletal limits. There are limits. They've got lines on paper connecting all of them, don't they? Is there a limit how much different a bacteria can be? Why on earth would they make me pay to have all the kids teach that a protozoa can turn to a frog and a fish and a mollusk and a butterfly? There's a limit how far protozoa can change. That's been observed. They make baby protozoa every time. But no, they want you to imagine they're all related. This is SpongeBob imagination stuff. It's completely 100% stupid. Tell them I said so. Go ahead.
Okay, Ken, thank you very much. Hank, thank you for your question. I want to now, before I get to the next guest, and Brock, I see your hand up, so we'll give you the opportunity for another question in a second. Kent, in your response to Joel Duff and his promotion of whale evolution as one of the best lines of evidence for evolution, he has responded by saying, and I'm going to try and interpret this correctly, Joel, so correct me if I'm wrong. And so he says, to live in the water and never lived on land, common design, but didn't throw those parts out, question mark. I'm assuming he's talking about the so-called whale vestigial pelvis. But as you pointed out, why would the whale throw those out if they are necessary for reproduction? Ken, any thoughts, brother?
Why would we assume the whale ever lived on land? Nobody's ever seen a whale produce a non-whale baby. Nobody's ever seen a whale come from a non-whale. All that's ever been observed is whales produce whales. Now, man has maybe decided to classify them into, 20 different kinds of whales, whatever they got, I don't care. But they're still a whale. So to say they used to live on land and went to the sea is imagination. That's a religious belief. It's not scientific. Science is what we observe, study, test, and demonstrate. Look up the word science. I got my hammer here. Science comes from the Latin word "scere," to know. What do we know? We know cows make baby cows. Now that we know. We do not know that cows are related to whales or hamsters or pine trees. That we don't know. You can imagine that if you'd like, and you can find similar DNA code, but that you don't know that they're related. But they draw these pictures like, oh yeah, look at that, boys and girls, they're related. There we go, we got a line on paper. So I don't really understand was he making a question or a statement? I didn't. Can you put the last one up?
Yeah. So he put another comment and he clarified that was the end of. So apparently he was having a previous chat about these so-called olfactory genes, not vestigial organs. But Kent, this just goes back to what we were talking about with Andrew. They believe, the evolutionists believe, that there's pseudogenes found in the whale genome, and so again, they're just assuming that those really are broken versions of protein coding genes. And so if they're functional, it basically is the genomic argument. It's applied there, but it's the vestigial art. It's about function versus non-function.
Well, the fact that this incredibly complex code was copied from my dad to me. The DNA code has more lines of code than all the computer programs in the history of the world combined. All the programs anybody's ever written do not equal the DNA code of one person. So my dad copied that code to me. I copied that code to my son. He copied it to his son. I'd be willing to predict when my grandson gets old enough and has a baby, it'll be a human. I'll bet $10 on that.
Well said. Matt, you were going to say something, brother?
Yeah, here's an interesting thing about the Pachycetus wolf-like creature that moved into the aquatic and became a whale. That requires a lot of beneficial mutations, right, to move from land into an aquatic species in general. But it only has 1 million years to do so if you look at their evolutionary timeline. Now, look at the evolution of a wolf. How long ago did they supposedly evolve from a wolf to what we have today? They have about 800,000 or 800 million years. That's a very long time we've had the wolf. 800,000 years. That's almost 1 million years. That's what it took Pachycetus, which was like land mammal, to move aquatically and become one of the largest mammals on Earth that we have today. So if a Pachycetus can do that in just 1 million years, then how come the wolf is basically identical to the wolf over 800,000 years, yet they exist worldwide on every continent on Earth? You think if there would have been an adaptation for the wolf to adapt and change and to move into a new environment, kind of like the Pachycetus needed to move into the aquatic region for whatever reason that was. Right? It moved from the aquatic location onto land, then it evolved back into the ocean again. Kind of strange there as well when you think about that. But I don't think that there's enough time for it to acquire that massive amount of mutations beneficially to move into the aquatic zone to begin with. Then when you compare it to the modern day wolf, again, we see almost the exact amount of time frame for the wolf to have diverged into something like an aquatic species, and it doesn't have any change at all, yet they exist worldwide on every continent. I just don't see the story lining up with what they're saying. It almost matches the wolf, and we don't see that in the wolf at all. So very strange.
Excuse me.
Well, I'm just going to have Kent respond, and then we'll go to.
Okay, that's all very good and very true, but you're assuming this time frame that they wish they had, which I think that's provable. It's not. I'm doing a whole series every Monday and Tuesday night on my channel, Genesis Baptist Church. You can't have time. There's ways to prove this universe cannot be billions of years old. And I've been doing that on episode 7 tomorrow night. Secondly, we don't ever see any changes like this. That's imagination. And you're assuming also that the fossils mean something. They say, well, in the fossil record, I say, stop right there. There is no such thing as a fossil record. There are fossils, trillions of them. They probably all formed in one big flood in the days of Noah. Fossils aren't forming today in any significant numbers, maybe not even at all. Nobody ever sees one. How many buffalo died out west in the last 200 years, and how many fossilized? Tens of thousands died, none fossilized. There's a fossilized clam in the closed position, indicating it buried alive, like Noah's flood would do. I got the fossil right there of the whale bone they're talking about. Supposedly this thing made it reproduce. Supposedly this is evidence it used to walk on land. No, it supports the muscles that support the whale's penis, 15 feet long. It had nothing to do with walking on land. But they teach this stuff like it's some kind of science, and it's not. They're so desperate to not believe in God, they'll believe something as stupid as believing a whale came from a protozoa over millions of years. You can't have the time. You can't have any fossils count. When you find a fossil, you can't prove it had any children. Can you? You find bones in the dirt, Pachycetus. How do you know it had any children? You found bones in the dirt. That's all. You couldn't prove it had any children that lived. So there is no such thing as a fossil record. I don't even give them credit for that. There's no such thing as a geologic column either. They say the top layer is younger. I say, really, where did it come from? How can the layers be different ages? Are they coming from outer space? This whole geologic column started being taught in 1830. It's got to be one of the biggest lies in history. There is no geologic column, no such thing as a Cretaceous period. All the layers probably formed in 1 year in Noah's flood. But I'm not demanding that be taught in schools. They want us all to teach that their stupid geologic column is true, and it doesn't. It's silly. It's just plain silly. So as I get older, I get more cranky about it. I'm tired of paying for it. Keep fighting to the end. Okay.
So I have a question. I would get
Yeah, Hank, go ahead with your next question.
So Exodus 7, 8, 10, Moses, via the power of God, turned a stick into a non-stick, turned a stick into a snake. So Kent, under the power of God, he transformed a snake into a non-snake. And if via God something becomes something else, that's evolution, isn't it? If God can turn a snake into a non-snake, we have evolution via God.
Well, for God to tell Moses to drop his stick and it turns to a snake, that would be, I would call a miracle. That's not evolution. We didn't see the stick slowly change to a snake. And when he picked it up, it turned back to a stick. And that was only for a particular purpose, to make Pharaoh let him go. I think after they got out of Egypt, that miracle ceased. Noah could lay the stick down at night and it would not turn to a snake. It was the purpose was it was a miracle. There's no explanation for it that I can say. But again, I'm not asking that to be taught as science. I don't have a scientific explanation for it. I believe it's true. I wouldn't put that in the category of science. I'd say that's part of my religion. I believe Moses had to drop the stick, it turned to a snake. Put his hand in his coat, came out with leprosy. Touched the water, opened up, they crossed the Red Sea. I think that's a miracle. I believe it strongly. I couldn't prove it scientifically. They want me to teach that everything came from a protozoa. That's not science. They can't prove that scientifically. That's a miracle. But they won't admit it's a miracle. They want to call it science. It's dumb, real dumb.
You know, it would take an ungod-guided miracle to take a rock to a whale, or a rock to a human, or a fish to a fisherman. Oh. And so, okay, Kent, I appreciate that response. Hank, thank you so much for joining. Brock, if we have a chance, we will get back around to you, but I do have...
Hang on 1 second. Donnie?
Yes.
Somebody made for me a rock with Grandpa on it. We now have... We're going to make them and sell them in our bookstore. Grandpa Rock.
Yeah.
Thank you. Go ahead. Sorry.
Ken, I love all your props. The Imagine, no show is complete without SpongeBob at least making one appearance.
Oh, I got a bunch of SpongeBobs here.
Yeah. There's the famous one.
The big one, yeah.
The Wade the Wizard debate.
Yeah. Oh, I got... Somebody sewed on the pocket for me, Professor Dave. Yeah. SpongeBob. Just imagine you're related to a strawberry. Yeah. Probably might be. Anyway, go ahead.
Hope, dream, and imagine, brother. Okay, we're going to move on right to the next person here. So we've got, okay, we're going to go Alec Cox with a question. Good to have you, brother. And then we're going to have to start doing some speed rounds as we move towards the 2-hour mark, which is when we're going to wrap it up. So, Alec Cox, good to have you. Quick introduction. And then, Alec, feedback. Major feedback coming from your end, Alec. So I've muted you. Okay, we're going to try again. Just 1 second, Alec. So, Alec, if you can unmute yourself, I'll say something. We'll see if you...
How's that? Huh. Sweet. Hello? Yeah, turn it down a little bit. Hold on.
We can hear you.
Hang on a second.
Yeah, I'm going to turn down your volume. Okay, well, we got to move on. So, Alec, if you can figure out how to fix that, we'll come back to you, brother. No, there's still some feedback. So, we'll come back to you in a second. Diaz, good to have you. I think, again, this is your first time, too. So lots of first-timers here in the open mic discussion on Standing for Truth. So, well, I guess he got raptured. So we're left behind. Okay, let's go to the next person. There's one person here who's been waiting backstage patiently, but I am unfamiliar with who he is. So I wasn't able to vet him properly. And so what I'm going to do, since with open mics, you can never be too careful. Okay, so Ruben, welcome to the show. If you can just introduce yourself and then maybe ask your question, and this will be my way to vet you, as we had some issues in an open mic that we did about a month ago, and so I want to avoid any trolls coming on. So Ruben, good to have you. Brief intro and then a question.
Well, I'm like studying to evangelism, and I don't know too much about like science and that. I'm more of a theologian, but I've had like science questions come up in evangelism, and one of those things that came up, which I don't really know much about, it was about how the Earth is proven to be old through the radioactive decay rate, and apparently this is apparent in the nuclear, what do you call them? The nuclear power plants. I don't really know anything about that, but I thought you could give me some insight.
Okay, well, I appreciate it, Ruben. Thank you very much for the question. I think so. The question for Kent, I think you might be muted on your end, brother, but it sounds like he has a question about dating methods, radioactive dating methods.
Am I muted?
Yeah, Kent, you're good now.
Yeah, I'm good. Okay, I'm not muted here. Well, first, the radiometric dating methods, carbon-14, carbon-12, rubidium, strontium, lead-208, lead-206, all these methods were invented in the last 60, 70 years, okay? So if they started teaching the Earth is millions of years old way before that, because they needed millions of years for their theory. If I told you a frog can turn to a prince if you kiss it, you'd say that's a fairy tale. But a frog can turn to a prince if you wait millions of years, and now it's no longer a fairy tale. The new magic ingredient is not a kiss, it's time. So the whole purpose of all the radiometric dating methods, and I cover them very thoroughly on my video number 7. If you get my seminar series, get a copy of it here. My creation seminar series is, well, got them here somewhere. Okay. 18 hours, $50 for the whole thing, all on DVD. When you're done watching it, you can send it back, get your money back, minus the shipping cost. My DVD number 7, question answer, I give a 30-minute answer to your question. How carbon dating does not work. It's based on some very obvious assumptions. Has there been no contamination? Has it been the same decay rate? I use the illustration. If you walked into a room and found a candle burning on a table, the candle's burning, and I ask you the question, when was it lit? You say, I don't know. It was burning when I got here. Well, let's do some science. Let's measure how fast it burns. We can do that. Let's say it's burning an inch an hour, okay? And let's measure how tall it is. We say, oh, it's 7 inches tall. Here's our 2 scientific facts. It is 7 inches tall, and it's burning an inch an hour. Can you tell me when it was lit? Well, no. Now you'd have to make some assumptions. How tall was it when it started? Has it always burned an inch an hour? Are there any things that affect the burn rate? Well, yeah, a slight breeze blowing through the room, the thickness of the wax, deformities in the wax, gunpowder in the stem, in the wick. There's numerous things can affect the burn rate of a candle, okay? So I think that with carbon dating or any of these, they're all based on a decay rate of something like that radioactive element, and there's obvious assumptions. And so I give like I said, a half-hour answer on my video 7. So I would encourage you to go to drdino.com, D-R-D-I-N-O, and order a seminar set, $50. When you're done, send it back if you don't want to keep it, but watch video 7. It's got a long answer. None of the decay rates will prove the Earth is billions of years old. None of them. Some may give numbers that are in the billions. That doesn't prove the Earth is billions of years old. So I cover all that very thoroughly on that topic. Oh, I think my computer, no, my battery, getting low. Okay, go ahead, Donny.
Okay, Ruben, thank you very much for the question. Was there a quick follow-up, Ruben? And then I think we're going to move on to the next person as we're doing speed rounds.
I was just wondering, because I've already heard that before, but they were talking about how like the nuclear power plants, if they didn't know the constant decay rate, then we wouldn't be able to have them properly functioning, and they could like blow up or something if we didn't know. But I don't really know anything about it. I was a bit out of my element.
I think they're pretty accurate on the decay rate. I wouldn't argue that. That's scientific. It's like measuring the rate that candle burns. I think we could get an Olympic stopwatch and measure it down to the nearest bazillionth of a second. Okay? Still, there's assumptions. How tall was it? I don't know. Has it always decayed at that rate? We know a lot of things affect the rate of decay for all the different elements they're claiming. Plus, it doesn't answer the bigger question. How did those elements get here to begin with? They say the Big Bang produced hydrogen. Well, excuse me. There's a periodic table you got to go through, and hydrogen's only the first one. You got to get chemical evolution. How did all the elements evolve? This is a serious problem. You can't fuse past iron. So they say the Big Bang produced hydrogen, maybe some helium, maybe some lithium. Okay. How do you get uranium, platinum, and gold and silver? I'd like to know how to make hydrogen gas into gold, that's for sure. So they're based on the assumption that these higher elements like uranium can decay down at a certain rate. You're not answering at all where the uranium came from. It's nothing but a religion, and they're welcome to it. I don't care what they believe, but they should stop calling it science. Okay, go ahead.
Thank you, Kent. Kent, out of curiosity, do you believe that God would have created the original rocks with radioactive elements, or did those come about later?
Well, if there's a purpose for it, I ask people to sort of answer that question. How old was Adam when God made him?
Right.
0. How old did he look? 70. Last year it was 69. So he had to make 2 full-grown adults. Which came first, the chicken or the egg? Well, 2 chickens. Yeah, has to. So did the earth look old? Well, probably not to Adam. He knew God. He watched God make a lot of stuff. So some things are just necessary to have. Did the trees have rings in them? Probably, because tree rings provide strength. The hard ring provides strength. The soft ring provides flexibility. Trees have to be both strong and flexible to go in the breeze. So yeah, I think the trees probably had rings. The first day God made them, probably had rings. So maybe he made uranium with and potassium and argon, all these different elements. I wouldn't argue with that. When I get to heaven, I'll find out. Those who aren't coming to heaven, we'll try to get a message down to you. I don't think I got email in hell, but we'll try. Okay.
Okay, great response. So basically, if hypothetically scientists were to take some of those rocks right after an hour after creation, and they were to do potassium argon dating or uranium lead dating, they'd probably come back with dates between millions to billions of years, even though those rocks were just created.
There may be a reason for this decay process that is useful that we don't know about yet. Maybe rocks need a little bit of potassium, a little bit of argon.
Right.
We can't assume that all the argon came from potassium. You can believe that, but that's an assumption.
Matt, you're currently finishing up a book that you've been working on for a while. Didn't you discover that a lot of these radioactive elements, they are necessary for just heating up the earth, energy for plants? You understand this topic more than me, but what was your discovery there?
Yeah. We can get into that. But one of the things is that we see potassium is necessary for every cell in your body. When you go buy fertilizer, it's got NPK. So potassium is vital, but potassium is radioactive. But it doesn't really matter because the human body can filter it out as we get it in, so we can never toxify ourselves. We can never get a burden from it, from natural foods. Like you can eat all the bananas that you want, but you can never accumulate too much of it to be a problem. But the world needs it. The plants need it to survive, and so do we. So clearly they have a very vital purpose, especially when it comes to potassium. Yeah, then we talk about the earth itself. What is it powered by? No one's ever been to the core, but it could be powered by potassium itself. You know, it could be powered by uranium. We just don't know.
Very
good.
There's
nothing stopping a miracle from happening over what seems like billions of years.
Why not a miracle over a billionth of a second?
I don't see why not.
God doesn't need time. We're the ones that are stuck in time, not God. Have you ever wished you could go back just 5 seconds and undo the dumb thing you just did? Yeah. See, God's not stuck in time. We are.
I'll just ask for forgiveness.
All right. All right. Well, okay. Thank you for that one. So let's move on. We've now got Bumblebee, another evolutionist here. So good to have you.
Hello, Donny.
It's great to have you for the open. I think this might be your first time here on one of our evolution open mics. And so why don't you give yourself a brief intro and then pick a point or topic that you'd like to go back and forth with.
I'm Bree from Hive Science. I have a channel where we talk about science and debunk bad science and all that good stuff. I'm sure you'd all appreciate every Saturday morning. Join me live from the Hive for my show, and we'll teach you a little bit. Now, I do have a question for Kent because he just brought it up earlier, which is convenient because that way it leeways right into it. Ken had mentioned that where do the layers come from? And I'm pretty sure Kent's probably done edging on sidewalks and stuff, like with his weed eater or his mower. And I can't imagine he's doing that year after year and still doesn't know where all those new layers come from. So I just wanted to get clarification on that.
Okay, well, the layers on your do edging on your sidewalk and the layers of soil building up, that's being moved from one space to another. Does that now change the age of it?
No, it's piling layers on top. Oh, sorry. Go ahead.
Yeah. If I shuffle a deck of cards, does the top card become younger? That's what you're doing. You're shuffling already existing material. But yet they're claiming in their geologic column that the layers are younger on top. I don't claim that my sidewalk edging. If I edge my sidewalk, I don't claim the layer on top is younger. It got blown in from the neighbor's yard. That's all. It's still the
layer on top grew over top, though. It didn't. It grew over top, and then the bottom layers died, and it turned into soil underneath there and broke down. And there's layers upon layers of. It's older layers underneath and that grow over your sidewalk, and younger layers on top. That's demonstrable.
Well, no, technically, every molecule in that on the whole planet should be the same age. If the Big Bang exploded at 13.772 billion years ago and 28 years now.
Cosmology is way out of my framework, Kent. But let's talk about the ecology of it, though, because animals and plants and funguses die back and form layers upon layers that die back and form into soil combined with minerals. And that's what we call soil. And those layers get thicker and thicker. And where they can be deposited by water, which I know you're aware of, and they can be deposited by wind too, and you get like louse formations. Are you familiar with those paleosols of any kind?
Okay, go ahead, Ken.
Hang on. If the rabbit eats the neighbor's grass from 2023, comes over into my yard and poops on my grass, and it grows, it's still the same molecules. They're all the same age. Every molecule on this planet is the same age, whether it's 6,000 or 10 trillion. Every molecule is the same age. Moving it from here to here does not change the age of it. So soil's building up or layers building up. Shake a jar of dirt, it'll settle into layers for you. Is the top layer younger? Let me get my display here. Let me ask you a question here, Bree. Here. If I flip this thing over and it makes 20 different layers, which it will eventually, is the top layer younger? No, they're all in here at the same time.
Yes, it is younger. As far as when they were laid down, it was laid down before the layer above it. Yes, it's younger. Like, yes,
it doesn't
absolutely
make it younger.
So if I shuffle the deck, it was laid down later.
Think about your logic.
Younger layer.
If I shuffle a deck of cards, is this card now younger because it's on top? Oh no, now this one's younger. I moved it. All you're doing is moving pre-existing cards into a new stack. They're all the same age. All of them. Every speck of dirt on the planet is the same age. There is no such thing as a geologic column. It does not exist. If the top layer is actually younger, it had to come from outer space.
The soil is the soil layer that's in a river valley. Is it younger than the soil that's up in the mountaintops?
As far as are you measuring the age of the soil or when it was laid there?
The age of the soil itself, as soil.
They're all the same age. If I shuffle these
all
cards,
soil's the same age. Okay.
Now this card was put on top at 913. Okay. If I shuffle it later, now this card's put on top at 914. You're taking existing dirt, moving it around, and claiming you just changed the age of it. No, you didn't. All the layers are the same age. How can it not be? Plus, all over the world, petrified trees are found standing up, connecting all these layers. How on earth can you guys claim these layers are different ages? Can you blow that up, Donny? Here we have petrified trees standing up, running through all the layers. They're found all over the world. And yet you're claiming these layers are different ages. It's simply baloney. A tree's only going to stand around a couple years. Dead tree. Petrified trees in the standing position are found by the thousands. Up in the coal mine in Birmingham, Illinois, Birmingham, Alabama, they find all kinds of petrified trees standing up, running through the seams of coal. It's a common find. You don't have to look far for it. Up in Joggins, Nova Scotia, there are hundreds of them along the banks of Joggins, Nova Scotia. So I cover this on my video number 4. The trees prove the layers formed before the tree could rot. That would be 1 year. Now, if you shake up a jar of dirt or shake up this thing, it'll make multiple layers in minutes. I think Noah's flood made all the layers in 1 year. The tide coming up and down every 6 hours, 12 and a half minutes. If the tide's coming up, that means the water's rushing into the tidal bump. When the tide goes down, the water's rushing out. And from one side, it has to be rushing in at the same speed the Earth is turning. If the tidal bump is held still while the Earth spins, from this side, the water's rushing in at the same speed the Earth is turning. Well, that depends on your latitude. At the equator, it's 1,037.6 miles an hour, I believe. At the North Pole, it's 0. Sideways moving water will make layers quickly. All the layers we see in the Earth, I think, were formed in Noah's flood. They're not different ages. They're all the same age. But I know the geologic column is your Bible, and it's baloney. You ought to throw it away. There's no such thing as a geologic column. Doesn't exist. The layers form quickly in Noah's flood.
Can I just say that was fantastic how you took the conversation from me talking about the layers of soil laid down to you're talking about the rotation. You're by the end of your speech, you're talking about the rotation of the Earth. You've gone through polystrate fossils and everything else. I'm like, whoa, that's a lot of data you're throwing at me, my friend. And I know you've talked to a lot of people about all these topics and you've been over this stuff again. I didn't want to rerun the whole things over again. That's why I was trying to bring you something new here, Kent. That's why I was bringing up the paleo souls, because I'd never heard anybody engage you about it. And those are actually soil deposits that are fossils of environments, like entire environments fossilized with fragments of the life that lived there. So we know how long it takes for these types of environments to change and form, how long it takes them to lay down, the amount of layers that they take that we find in the fossil record. We have more than just radiocarbon dating for this. We can actually
one at a time. Don't slap and run. Let's finish the topic. I did answer your question. If a rabbit eats the neighbor's grass and poops on my yard, it adds new material to my yard. It's still the same molecules. It didn't change the age of them. Every molecule on the planet is the same age, whatever you want to choose. I think I showed you evidence. The layers form quickly because you have trees connecting all of them. I think Noah's flood did it. If you think they're different ages, I keep asking the question, where are these new layers coming from? The soil you're talking about is coming from the neighborhood.
I don't disagree with that. I just think it's a new layer. I don't disagree with that. It's coming from pre-existing material, laying down new layers of old molecules. I'll agree with you every day about that.
Then it's the same age. It's the same age then.
But the layer has a new age, though, right? There's a new layer of old material. It's a new layer on top of an older layer, on top of an older layer, on top of an older layer. It's a new layer that's laid down. It can be pre-existing material. It can rain down from space if you really want it to. Some does. A certain amount, it does rain down. But most of it is deposition. Move from one place to another and then back. And then move from one place to another and back.
Watch this. I'm going to move the 6 of diamonds to the top. Wow. Now it's younger than the rest of them. That's your logic.
No, you misunderstand you misunderstand what we mean by younger. It means it was laid down later, not that the material is necessarily younger than the material below it. It was laid down and it's a younger layer. Not
I understand.
Younger material.
I'm going to lay this down on top. I just made it younger. Wow. Who'd have thunk it?
That's a younger layer of cards. Yeah. I agree.
But wait, Bree, don't you believe that they date those layers and they actually are older than the previous?
Sometimes you have inclusions from younger or older within the formation.
So it wouldn't be accurate for you to say that they are all the same age. You believe that they're different ages because we date differently.
I'm sorry, I spoke over you. I'm sorry, Sam. Go again. Or not Sam, you're not Sam, sorry.
Oh, yeah, no. Yeah, my name's Sam. No, I was just saying you do believe that they are different ages because you date them differently.
Yeah, but the age of the material we're not going to take that into the exact consideration as to the age of the layer. A layer that rolls down off of a mountain might be older than the soil laying down in the valley when it falls down on top of it. That can be accounted for. And we can see inclusions like that. And we should expect to see inclusions like that.
Ken, what if a critic were to say, so for example, in the chat, Joel Duff, and Bree, we'll go right back to you, don't worry.
He has his hand up is all I was saying.
I'm sorry, Brock, just 1 second.
Yeah.
Okay, Brock, you go first, and then we'll get Joel Duff's objection here.
We can't hear you. We can't hear you at all.
You're all
Name is
muted.
gone.
Okay, you're good, Brock. Go ahead.
Everybody's name is gone. Like I know it's Donny and Ken, but everyone else's names, I don't know y'all's names because it all just went away.
Doesn't matter. What's the question? Does not matter.
I was just curious about that.
Oh, is that what you're curious?
Yeah,
You have a
I
question,
got
Brock?
another thing.
Let's
It's
hear
not.
it.
It's
Don't
not
worry.
about the layers. It's about radiometric dating. So I don't know if we're supposed to talk about that at this moment.
Let's stick with the. We're going to stick on the layers for now because that's the topic we're on. But Brock, we might get a chance to come back to you. I want Kent to give his thoughts on this.
He has some
And so-
slides ready. I know he does. He always does.
Okay.
And we're going to have to set up a full debate between Bree and Kent. I think that'd be fun.
Sure,
And
bring
so,
it on.
So before we move back to Bree's follow-up, Joel Dev says, I don't think he's fully getting it, Kent, but he's saying, so Mount St. Helens, by this logic, is the same age as the rocks at the bottom of the Grand Canyon. What would be a good response to that?
Absolutely. Every molecule on this planet, clear to the center of the Earth, is the same age. Whether it's 4.6 billion or 13.772 billion or 6,000. Every molecule is the same age. All Mount St. Helens did was take stuff out of the Earth, blow it up into the air, and it landed on the neighborhood, and it's still the same age. It didn't change the age of the molecules. Yes, Joel, think about it.
And you're basically saying that these layers were created, most of them during the flood. And so they're all what? Max a few months apart, year apart.
I can demonstrate clearly that layers form rapidly. Anybody can do that. There's a video been made out for 25 years ago, experiments in stratification.
Right.
The layers form sideways, multiple layers at the same time. Just type in experiments in stratification. The guy's got a French name about this big, but it's a classic video from 40 years ago showing when you pour sediments into moving water, they form 8 or 10 or 15 layers horizontally. The layers don't form this way, they form this way. And the tide going up and down every 6 hours, 12 and a half minutes is going to produce a phenomenon called tidal pumping. The water's rushing in and out of the tidal bulge. That's common sense 101. And it's the sideways movement of this water every 6 hours, 12 and a half minutes that's going to make thousands of layers. The geologic column does not exist any place on Earth. Sometimes they admit it. I got quite a collection of public school textbooks here. Let's see. This one right here. If there were a column of sediments, unfortunately, no such column exists. There is no geologic column. You don't ever find them in this order everywhere. Somebody will say, well, yeah, we found them in North Dakota in one place. That's like saying, well, we never find all 4 aces together in a deck of cards. Well, you might, just by random shuffling. Chances are, we could probably calculate the chances of that, but it'd be mathematical, near impossibility, probably near impossibility. But see, the whole theory, their whole religion of evolution is based on this dumb geologic column, which does not exist anywhere. I just point out, where is it? If it existed, like they say, it'd be 100 miles thick. It's just simply not true. I'm sorry. If that's your Bible, go get a new Bible. It's not true.
You got to enjoy those timestamps on those dates.
What?
I enjoy the timestamp, the dates, 1999, 1990, or 1989. Yeah, good stuff.
Folks, listen. Watch what she's doing. Now she's saying, because it's an old date, therefore it's not accurate. So knowledge and science changes. When I was a child, 2 + 2 was 4. It's still 4. They didn't have to change it. See, truth never changes. In your mind, because it's an old date, therefore it can't be accurate. Well, it was true back then. It's true to now. It's true now. Show me an example. Explain how can these layers be different ages? Are they coming from outer space? Simple question, Bree. Don't change the topic. Doesn't matter if somebody wrote it in 1840. Newton made up the laws. Law of gravity hasn't changed since he made it up. He defined something that already existed. The fact that it's old is this is a straw man you're making here, Bree. You won't get by that with me. Okay, find a 5-year-old. Maybe you can get him to believe it. Go ahead.
Go ahead, Bree.
Oh, okay. Yeah, no, but we do learn new things in science, don't you think, Kent? Don't we make new scientific discoveries all the time?
You didn't listen to me. I agree. We learn new things. I said truth. Watch my lips. Truth doesn't change, no matter what date's on it. 2 + 2 was 4. before, a long time ago.
And the truth that the layers of soil and sediment are laid down sequentially, and you can measure time through them, is also a truth, though, right?
You want to measure when it was laid down, or do you want to use potassium argon dating to measure when it formed? See, when it formed, they all formed at the same time. Every
my
molecule.
field is more about when they're laid down. I'm more about soil than I am necessarily fossilized.
What difference would it make when I laid it down? If I laid it down, let's see. Now we got the 2 of hearts. I'm going to lay it down. Oh, now it's the youngest.
No, wait. No, stop right there. Wait, right there, and then a forest grows on that 2 of hearts, and then that forest dies, or the landslide slides down on top of it. Now you got a forest stuck in the middle of there, right? New layer.
I moved the dirt. Listen, I moved the dirt, a landslide from here to here.
Yeah,
and you're saying
that another deck.
So it made it younger because we moved it in a landslide?
That's a new card added to your deck, a brand new card. That card's newer than the cards underneath it.
This card's newer than the rest of them. Is that your logic?
No, if you said take the card from over here, that took it from a different deck and slid it right down on top of it.
From a different deck and put it on here. I don't know when the
deck's
a
newer card.
Maybe all the decks were printed at the same. I know this. Every molecule in this card is the same age as every molecule in the universe.
We'll be talking about when the layer was laid down, though, not how old the material is, right? Let's stay focused.
Watch this. Now we're going to put the 3 of diamonds. I'm going to lay it down on. I'll tell you what. I'm going to have 2 decks of cards. Here we go. I got 2 decks.
Donnie, you're having too much fun up there. Stop.
I'm going to move one. I'm going to move this one. I'm going to move it. I don't even know what it is yet. Oh.
Ooh.
I'm going to move it over to this.
Can I guess the card before you turn it over?
3 of diamonds.
Dang it. You didn't give me a chance to guess, Kent.
I feel like I'm trying to explain colors to a blind woman here.
Yeah, I can see how this could be frustrating for you. I'm just trying to understand your point of view. I think that new layers do come in. New layers and new soil and new deposition does come in from space. Not nearly as much as comes in from other layers and other formations. Certainly, rivers carry it. The wind carries it. It drifts in the tides and in the atmosphere. Soil is moving all the time, and in some areas, its deposition is heavier than others. Some areas it's so eroded you can't grow. They can't grow stuff on it anymore, like the Holy Land.
Hang on a second. Let's see. Well, I think that the geologic column does not exist anywhere. It's the Bible to the evolutionist. It's easily provable that all the layers formed rapidly. They form horizontally, not vertically. It is common sense. If the top layer is younger, where's it coming from? I believe mountains form. I think we see layers all over the earth. I taught earth science for 15 years. I'll debate any earth scientist you know. The layers do not exist. They're not different ages. I agree they exist. I think they all formed, or nearly all formed, because of Noah's flood and the contortions that the crust went through. When you look at the layers closely with magnifying glass, like these bent layers, they don't have internal fracture marks. They all were like a stack of pancakes and bent while they're soft, and then they hardened. If the layers were different ages, the bottom one would crack when you try to bend it. No, they're not. I got pictures of that. I showed that on my video number 4. So I'm sorry somebody taught you to believe in evolution. I probably helped pay for that, and I'm sorry for that too. But Bumblebee, come visit Dinosaur Adventureland. We'll give you the tour. You can get converted into some real science. God made the world. It was destroyed by a flood. The flood explains the fossils. The flood explains the shapes of the continents, why we have a continental shelf. The flood explains why we have all these fault lines, San Andreas Fault, Hayward Fault, New Madrid Fault, all formed because of Noah's flood. Why do we have thermal vents shooting hot water into the bottom of the ocean? I cover all this in my seminar. You need to watch the whole thing. Go ahead.
Oh, I've watched some of your seminars. I've watched them with some friends and stuff. I've talked to friends about coming down to see Dinosaur Adventureland too. That's why I brought up the groundskeeping thing, because I know you always like to keep it all trim and tucked down there and looking nice. So I figured that you knew a little bit about edging and would know that the grass grows over the sidewalk and deposits in soils underneath there when you peel it up. It's just the nature of deposition.
Yeah, Bree, we got a small herd of cows from Indonesia, zebus they're called.
Yeah.
They eat the grass. A couple hours later, they poop on the grass.
Fertilize
Did it change? Is it changing the age?
Yeah, there's a new layer with the feet. There's a new layer with the fertilizer on there, right? The cow.
So the new layer of cow poop is now younger than the grass they ate 6 hours ago. Okay.
Yeah, as a layer. Yes, it's younger than the
Okay.
grass where they pooped. Yes.
Okay.
All right, let me jump in. What we're going to do, Bumblebee, you and I will chat through email after this, and we'll set up
Okay.
your evolution debate with Kent. I think that would be fun. And then we
Bring
can
it
go at this for a couple hours, just you two. So,
Sounds
Kent,
fun.
you have given us so much of your time tonight. Earlier, we had Diaz who joined to ask a quick question. And whatever happened, you actually left us, Diaz. So let's give you the chance. Let's do 5 more minutes, and then we do want to wrap it up because I want to respect Kent's time. This has been a lot of fun. I've really enjoyed this, and hopefully we can do another one of these soon, especially during the summer. So Diaz, quick intro. I believe you told me in the private chat you're a creationist, and then ask Kent your question. Good to have you.
Hey, Donny, is my audio okay?
Yep. Much better.
Yes.
Yeah, I'm holding a cell phone right now. So, no, I was kind of hoping an evolutionist was going to still be on. I know Bumble is still on, but no, I wanted to say, psychological aspect. Number one, we could zoom out and live in a world where the Bible was actually talking as if it was Darwinian evolution, and it said the African person was a primitive species. Number one, everybody right now will call the Bible the most racist book in the world. Okay. And I would like the evolutionists to kind of study it as if the Bible said that. Would that alter what they call science? And I think that's something to really ponder about, Number two.
Yeah, but Diaz, do you have a question for Kent? He's running over the time he said he was going to be here, so we're just going to try to respect his time. Kent, we're grateful that you came on out. So, Diaz, if you have a question for Kent.
No, not necessarily. I agree with virtually everything he says, and
okay.
I guess I didn't understand the format too well.
No problem.
No, it was more of a comment about it. If I have to skip through, no worries.
Yeah, you want to just finish your thought real quick, and then.
No, it's for any evolutionists listening. Like I said, I would want them to live in a world where the Bible called the minority species the primitive species. What would you say? And if you can consider that you would call it racist, then apply that to Darwinian evolution. Yeah.
Okay, Diaz. Well, I appreciate it. Kent, if you had anything you'd like to comment there, then we got one last person, evidence of Christ in the bottom right, and then we'll wrap up your time here, Kent. Go ahead, brother.
Well, thank you. He's got a good point. The Bible is not racist. All men are created equal. We're all of one blood. We all came from Adam. Nobody's superior because of their skin color. Okay, I'm living in Alabama. I'm full aware of the racist problems. I've never met a black man in my life. I've never met a white man. I'm not white. Here, this is white. I'm not white, okay? This is black. I've never met a black. I've met dark brown, light brown. Here, there's the real Kent Hovind right there, okay? It's skin color. So the Bible is totally against racism. Now, Darwin's theory, though, says the preservation of favored races. The stronger race should survive and eliminate the inferiors. If you get one animal evolve a little better than the rest of them have to die to make this work. Suppose we had one animal slowly becoming a cow from an amoeba. It's a little better than an amoeba. Well, what about the rest of them? Well, they got to die. Plus, you got to have 2 of these evolve at the same time of the opposite sex in the same place. They got to find each other. You got a real problem, a lot of problems for evolution. Evolution is nothing but a religion. Nobody's ever seen it happen. Believe it, great. Believe whatever you want. That's not science. That's all. And I wish they would just simply admit, hey, it's a religious belief. Stop calling it science. Admit it. You worship at the Church of Darwin or something, make a church, you do whatever you want to do. But quit calling it science.
Very good. Kent and Diaz, appreciate it. Okay, last guest on the panel, Evidence of Christ. Thank you for your patience. Thanks for joining us. It's been a packed house tonight. It's been a lot of fun. We've had a good mix. We've even had some polytheists join, so there's a first. Okay, Evidence of Christ, brief intro. I think it's your first time here as well. And then your question or comment. Oh,
no
I think you might be, it doesn't say you're on mute, but we don't hear any sound coming from you. So it could be your end. Just make sure to check your mic settings or speaker.
Nothing.
It could be because you have a headset on, which means you have to click the right feature in settings. And so when you go to settings and click audio, you're going to want to make sure that it's your headset that's coming through.
Unplug the headset. Start talking.
Sometimes you have to leave and come back. That was, oh, you did.
Okay.
Okay, well, we'll make, oh, actually, you know what? Evidence of Christ. If you want to give us one more try, audio test. Okay, still not hearing anything, which means we'll make professing preterist here. We'll make you the last guest.
Well, Donny, you mentioned about having more of these debates this summer. That's fine. Have one every week. I'll take them all on.
Let's do it. Let's do it. This has been fun. We've had a great audience the entire time. And yeah, we've basically got endless guests here. So we're going to set another one of these up soon. We're going to set up a one-on-one with Bree and Kent as well. Professing preterist, if you're there,
I am here.
Thank you for being here. We'll make you the last, I guess, guest for Kent before we allow Kent to get some rest. Kent, I'm sure it's been a busy day for you, brother. So brief introduction, and then if you had an evolution-related question, go ahead. Floor is yours.
Yeah, thank you. So I do have a question for you. So Dr. Kent, you said that you believe that God created the earth, correct?
Absolutely. And the heaven, everything. Yep.
Do you believe that he would destroy it?
Yes. It says he destroyed it once with a flood. He's going to destroy it next time by fire. It says the elements shall melt with fervent heat. That's what the book says. I believe that.
So when he destroyed it with the flood, it was utterly destroyed completely and he had to remake a new one?
No.
Okay.
I can destroy. I can wrinkle up a piece of paper and let's see, and fix it. I think we're living on a world that's been flooded, messed up badly, and fixed back. Now we're living in a junkyard. The Bible says in Isaiah 45:18 that God created the earth to be inhabited. That's why He made it. Today, 3% of the earth is habitable. 71% is underwater, 10% is under ice caps, 10% more is desert, 3% habitable. We are living in a junkyard compared to what Adam and Eve saw. It's the same planet. It got totally wiped out by a flood. So no, he didn't have to remake it. It's just left. We're living on the leftover usable parts of a junk car.
And then, so at the end of it, it gets completely obliterated when he destroys it the second time?
Well, it says he's going to, its elements are going to melt with the fervent heat, and then he's going to make a new heaven and a new earth. That's what the book says. But the argument tonight is not about what the Bible says. The argument is, where's the evidence for evolution?
Where's the evidence for it? I was just curious because you had said that you believed he created it, so I just didn't know if you think he would also completely eradicate it as well.
Well, because it says he's going to make a new heaven and a new earth, maybe because this one's been contaminated and because he can make it, doesn't cost him anything. Maybe that's why. I don't know why he's going to do it, but he can start from scratch and make hopefully a whole new planet. He can take dust and turn it into Adam and Eve. I believe that.
Yeah.
But again, I'm not demanding that be taught as science in our schools.
Gotcha.
Well, he needed a rib to make Eve, though. He couldn't not just plain dust. He had that extra ingredient.
I didn't catch the question there. What
I said he had to have the rib for Eve, though, so he needed that little extra ingredient, that little pinch of Adam, if you will.
Well, yeah, he made Adam first because he didn't want any advice on how to do it, and then he made Eve out of a rib, and so wise move, God. And yeah, I'm sure he had to add all kinds of things. Take a rib and add the rest of the body. Sure, my God can do that, but I'm not demanding that be taught as science. I would never claim that is science. I admit that's my religious belief.
All right. Well, all right. This has been fun. We're going to set up another one of these open mic challenges soon. And we're also going to start incorporating a lot more of our evolution challenge debates. Kent, last year alone in our evolution debate challenge series, I think he did about 60 in 1 year. So that's got to be some kind of record somewhere.
No problem. Do it again.
Okay, brother, any final words from you, Dr. Kent, the science gent? This has been fun. We've had a lot of good back and forth with a lot of different variety of views. And so, yeah, Kent, over to you. Final words, final thoughts.
All right. When all is said and done, you're all going to die. Bumblebee, someday you're going to die. I hope it's a long time from now, but you will die. Then what? Do you know for sure what happens when you die? I know for sure I'm a sinner. I deserve God's judgment, but I've been forgiven based on what Jesus did for me. I would encourage every one of you to give up on that stupid evolution religion and realize there's a creator. He did it for a reason, and he's going to be the judge one day. The Bible says at the end of time, the scoffers will be willingly ignorant of the creation and the flood and the coming judgment. Put my slide up there, but the creation, the flood, and the coming judgment of God. 2 Peter chapter 3. You scoffers are ignorant of what the world was like, the creation. I cover that on video number 1 through 3. You're ignorant of that flood. I cover the scientific evidence for that on video number 6. You're ignorant of the coming judgment of God. I've got a whole series on that called Whoa, What on Earth is About to Happen, according to the Bible. You may not believe it yet, but I would encourage you to at least understand what that book says, because what if it's right? If evolution is true, I haven't lost a thing. I've lived a wonderful life. Everything's fine. If creation's true and you're wrong, you've lost it all. I'd encourage you to really think about that. Pascal's wager. I can't lose either way. Thank you so much for having me, Donny. Let's do it again anytime.
All right, Kent. Appreciate your time, brother. You go get some rest. Great job tonight. Lots of fun. And so we will let Kent get out of here. And me, Matt, and Sam, we will stick around until roughly the 3-hour mark. And again, we will definitely be incorporating more of these open mic challenges, or for anybody who wants to do just a 1 versus 1 debate with Kent as well, do reach out, and I will, get everything set up, get all the details. Bumblebee and Kent will set that up ASAP. And so anyways, we'll stick around for a little bit. I've basically been engaging nonstop too for 2.5 hours. So I'm going to just take a 5-minute break and get a snack. So Sam and Matt will be taking over, which means any evolutionists want to bring up anything to Matt and Sam from Team SFT. Now is your chance. Sam, you look intimidating. I wouldn't want to be an evolutionist or an atheist challenging you, brother. So you take it easy on these evolutionists, will you?
It's just the brick wall. It's a facade, just like atheism. It's just
you got bricks for biceps too. Your arm curling those 65. So Sam, I wouldn't mess with you, brother. I'm glad we're on the same team. So why don't we start with Bree then, since you're the brave evolutionist on the panel, and I do appreciate that. Did you have anything you'd like to bring up or anything you've heard?
Well, I do watch your guys' content, but I've been following Indiana Joe and the guys over there. You all should collaborate with them more. You got anything planned for them with them in the future?
Oh, I'm sure Donny does.
Yeah.
Can I address your examples that you gave real quick?
Oh, sure.
So your responses, you gave one example of catastrophism. You said that one layer with a forest and such slid over another. Mm-hmm. But that would be inconsistent with your uniformitarian model. That layer would have to slide across an entire continent. And that would be an example of catastrophism again, which is inconsistent
over an entire continent. You have to elaborate on that, because most of the depositions not from landslides. Most depositions carried by rivers and waterways, some by the wind a lot, even more. Landslides are just something that's easy for people to visualize, a layer being laid down on top of another layer. Is why I use that. It's been by no means common. And it's
so these layers,
primary examples.
These layers don't cover large, vast masses of land.
Oh yeah, more so in days past. Now we've dammed all the rivers and stuff, but rivers used to annually flood and fill miles and miles.
Yeah, in some case they would be like the majority of, if not the entire continent.
Yeah, like if you went back even just a couple hundred years and looked at the Mississippi Valley, how it looked back then compared to now, you can see how it laid down layers and layers of silt every spring.
Yeah, so that's why I say it would be inconsistent with your model, because now you would need a mountain range that's high enough to provide all of this moving earth and the quantity to cover these vast pieces of land. And even if you had that, which you don't, it would not be an example of a slow, gradual process putting these layers down over time.
Why would you need a mountain range? Can you explain you lost me, because I don't know why we need the mountain range. Can you explain? Because not all rivers come from mountain ranges, right? Mississippi doesn't even come from a mountain range at its source. It's from highlands.
If those layers fell down from outer space, maybe you don't. But your example was a landslide, And landslides.
That was just for visualization. Landslides are, again, exceedingly rare, just to help you understand how a layer can be laid down on top of another.
Let me finish my thought before you go. Again, I'm addressing your examples, and I'm showing you why your examples are inconsistent and they don't work. In order for you to have a landslide, you have to have point A being higher than point B, and you have to have a sufficient amount of material to slide down. Things slide down. So your landslide example isn't going to work unless you've got a massive mountain and a massive amount of material to slide all the way across the continent numerous times to account for each layer.
Yeah, landslides wouldn't account for that. The way that type of deposition works is that it's annual growth throughout the summer, fall, and then there's the winter, and then there's the spring. The storms come in and wash all that dye back into the river. That's all the soil that is deposited downriver. That the deposition comes from growth, not from landslides. Like now plants growing in the area. Landslides, as I keep saying, are exceedingly rare, and I was using that as a visual model because Kent was showing his rocky silt deposit thing, which would be more akin to how a landslide would deposit, as opposed to how plants and forest growth and then die back, turn it into soil and being washed down, which is actually what we see evident in real time. That's how we have this fertile valley of the Mississippi.
Yeah. So here's what happened. You rescued your dilemma with erosion, but erosion, that's only going to add to the problem. We're talking about these layers building up.
Where does that, when it erodes, that's where it goes. That's where it goes to build up. Yeah.
Well, no, it would build up at the lowest point. You would say at the bottom,
like river delta.
Right, but these continents aren't a giant valley. You have these layers.
Well, they really are. You're between.
On one hand, yeah. So it seems like you're contradicting yourself, because on one hand you're trying to explain a process by which these layers would be built up. You appeal to catastrophism, but now you're giving examples. Now you're giving examples of erosion, and that erosion is going to remove the soil.
Yep, it'll deposit and remove soil, and that's why field management is actually what I was studying for. I didn't, but anyway, field management. That's why we have to transplant soil into different areas and such, because we have to rotate the deposition layers manually, because we've created artificial regions. The Mississippi Valley doesn't do what it used to do, where in the spring it would flood out and give nutrients to all the field lands. Everybody's farmland around here would get flooded in the spring, and then when the water would recede back, we'd have a fresh layer of really, really good soil left behind. But all the damming and stuff. So we see, I'm just giving you an example, say that we see this deposition in real time. We actually depended on it.
Yeah, your examples don't work, because now you're kind of appealing to these rare cases, which again are the bottom of these valleys, or these special areas that are the result of the erosion, carrying the soil, which the soil in itself. Let me just make one point, and then you can address it. And then Matt, I know you've got a lot more knowledge here than me, but this process of soil that you used as an example, it would be bioturbation. And so you're saying that as these layers lay down, you have worms and microbes and plants growing in these layers, and they create soil. But when we look in the layers of the geological column, we don't see evidence of bioturbation. So that's going to be a direct conflict with the example that you used, that you gave Ken.
But we do see bioturbation, right? In most formations, we can find some levels of bioturbation. We actually find a lot of burrowing animals are really prone to fossilization, because they get buried in their burrows. And then we've got things like there's places in the Grand Canyon, for instance, where you can see like burrows of like insects and worms and things of that nature too. But again, this isn't speculative stuff that I'm talking about with the soil deposition. That's actually that. I mean, we observe that they still work the Amazon that way, because they haven't destroyed the Amazon River Valley like the way we destroyed the Mississippi Valley. It's still pretty wild and untamed, and it still floods its basin completely and rolls back when they grow their crops in it.
Yeah, but you're zooming in and you're giving little specific examples of little pockets that we find within the Grand Canyon. But according to your example, these slow, gradual processes over time, the entire Grand Canyon should be evidence of bioturbation. In fact, it should all be soil, because the Grand Canyon, according to your model, your slow, uniform model, the Grand Canyon would have been built up with this soil forming process continually taking place for millions of years. So I don't see how at any point you would have any layer or piece of dirt that doesn't have bioturbation in it.
Well, you'd have different seasons where the soil was completely washed away, or where more was laid down this year than the last year. There's a lot of variability that you got to account for in that. But you look at when we're talking about geological time, you don't look at season by season. You look at an overall trend. This is kind of like how folks will look at the weather and say it snowed, so the climate change isn't real. That kind of argument. It's there's little variations that within the sedimentary layer process. And the paleosols are real, though. There really are layers of soil that tell us what organisms lived in the biome, what type of forest it was, what during what period it was, what sort of predators, what sort of herbivores. All the good information can be garnered from these little chunks of soil.
I also want to say that you're conflating soil with sediments. Those aren't the same thing.
I'm just dealing with the examples that that Bree used. Matt,
I'm talking about soil.
Add to that?
I would just say that the soil itself can be depleted very, very quickly. Like when we that's why the land near rivers does so good, because it floods and it goes over and remineralizes the soil. So we see lots of really rapid loss of minerals through the environment really, really quickly. So we're it seems like people were arguing.
I think we're all pretty much on the same page. The river valley is going to get fresh soil laid down all over and over again seasonally, probably. I think we could all agree on that.
Right.
Yeah.
Just to kind of, sorry, go ahead.
No, it's okay.
So I think an important term that you and Bree were discussing was related to something called sedimentary basins. So of course, different parts of the continent are experiencing different rates of uplift and subsidence, and that creates, like you were guys talking about, little valleys or pockets, so to speak. And of course, that happens in different places at different times. So of course, different parts of the continent are going to have more sediments accumulating there than in other parts. It's not like the whole continent is getting flooded over with sediment layers constantly all the time.
Well, let's shift to another topic. That was fun. That was good.
Okay.
Andrew, I know there was a few things that you were talking about earlier in terms of evidence for evolution. Everybody can get involved on this one if they'd like to. A couple of points you and Matt were going back and forth on as well, but we just didn't really have the time in that moment.
I forgot what they were exactly at this point, unfortunately.
Well, if you could present a line of evidence, and we'll have Matt get involved first, and then we'll kind of just go with the flow with that. So go ahead, Andrew. Andrew versus Matt, the much anticipated debate.
Well, I don't think me and Matt get to interact much nowadays, so I appreciate having me on. I guess let's see. The last thing we were talking about was the whole synonymous mutations, ubiquitous proteins things. So I did have a few other things I want to say about that. I guess if you want to reiterate some of the points you were making, Matt, just to kind of review some of them.
Oh, I was talking more about, I was trying to help Ken out and answering the genetic boundaries thing. Which was
right.
And then you moved into synonymous. That was with Donny, actually.
Right. Yeah. Okay.
If I didn't know if you wanted me to go into it or not, but
Matt, what are your thoughts on? Okay, so Andrew, correct me if I'm wrong. You've got these proteins that are shared across the biological world that fall into nested hierarchical patterns, and then the synonymous mutations within those proteins also form a hierarchical distribution. And you're arguing that those synonymous mutations aren't really doing anything specific function wise to the organisms. They're neutral, functionally neutral, basically.
For the most part, there are some cases in certain lineages where they can be under selection to do specific things, but for the most part, they're under very weak selection pressures. So yeah, pretty much for the most part overall.
Go ahead. I gave my thoughts earlier. I'll elaborate a little bit later, but Matt, go ahead. What are your thoughts, brother?
I would imagine that since they are in the synonymous regions that are already doing just a little bit of function, when mutations occur there, of course, they're going to have a little effect because they're actually doing very little. So like the first one that you had mentioned, what was that? It's a gene. It's a pseudogene that you mentioned.
Nanog?
Yeah. That one codes for stem cells, right? That one's still functional in mice, but not in humans or chimpanzees, right? So what it's doing would be a functional thing regarding stem cells. We don't have a problems with stem cells in our own bodies. We make them mostly through the femur and the rib cage and larger bones like that. So I would imagine that the reason why it's different in humans and chimpanzees is because the functional role through the process of the embryonic stage is where this gene actually functions. And so when you see like a particular area that's considered a mutation difference between a chimpanzee and a human, the kidneys, we see that the kidneys function completely different between the two. So what you guys would say is a mutational difference, we would say is a created difference. So it's just the difference between our models. We're saying that this is just an allele difference, not a mutational difference. So
okay, so two clarifying questions there. So first, when you're talking about the functional gene in mice, are you, because not all the pseudogenes or the versions of that gene are involved with the stem cell function. That's what the functioning version of that gene does. But I don't think that might be one of the pseudogenes, maybe, but I don't think it's one shared between chimps and humans. I might be wrong on that, but most of them don't carry out that function. So I guess first, could you clarify on what you meant there exactly?
Okay, no problem. That gene in particular, when it's considered functional, they had a lot of mutations as well in the mice one. It was considered broken, but they said mutations activated it and turned back on, and now it works like it used to originally. We would say no, those mutations were actually functional. That's why they were not really mutations to begin with. We follow mutations in a different view, in a different light. Remember, in our model, it's the nuclear DNA or created differences, and mutations that we see in the mitochondria. These are the regions that would be caused by the damage from the mutations and what separate us. That's what we trace back.
So you mentioned like kidneys. Are you suggesting that like different organs have different mutations and that affects their different functions? Or I'm not sure I quite understand what you're saying.
No problem. I'll clarify it real simple. Basically, what I'm saying is that when we look into a region and we would say that you guys are like, this is a mutational difference that proves evolution. We're saying, no, it's a created difference and it's functional, because when we're forming our kidneys and when primates are, they both form different types of kidneys. So they're functional regions, as where the evolutionary model would say that they're damaging, right? This mutation is either reached fixation that's beneficial and that's why it's doing it. We would say these are created differences and that's why they're different. That's all.
Well, I think the reason we're pretty sure they are all mutations, though, is because they kind of had the pattern that we would expect if all these mutations occurred. So, for example, there's because different mutations, and I'm sure you're already familiar with this, but because different mutations happen at different frequencies, let's just say they have a probabilistic nature. Like, for example, I can't remember which is which offhand. Transversions versus transitions, for example, like the pattern of going from a pyrimidine to a pyrimidine versus purine to pyrimidine, for example. Like those obviously happen at different frequencies in the genome. So the frequency that we see that happening naturally is kind of reflected in these different regions, for example. And I don't know if I'm making that clear, but like that's kind of how we're pretty sure that those are mutations, not just created there.
Okay, you're talking about statistical probabilities, and statistical
Right, yeah.
probabilities are great because that's what science is. The more improbable it is, or the more probable it is, the more it's likely to happen. So you're saying that because of the statistical probability of all those things lining up that just so happen to match the evolutionary pattern, it must be true. But then you can counter that argument yourself by saying, well, if we compare this very region over here, like cytochrome C to cytochrome B, we get a different tree of life. So then you have to go back and say, well, maybe it's because it mutated differently, right? So we're saying that, no, these are the created differences because of the beneficial functions that they apply to, because those were never considered in the evolutionary model. That's why they threw them away as junk DNA. And we said, no, they'll have a function. And therefore, that was the real big difference between our models, right? That's what put intelligent design kind of on the map, because, they don't really have too many predictions in their model. We, on Young Earth Creation, we try to have a ton of them. And that was the one that they actually got right, it seemed like. There was no real junk DNA. They're doing transcription. And though it's a little bit, it's still somewhat functional. And they had to say that, well, lots of time has passed, and that's why they gained their function back again. So we're saying, no, that was always their function. There is just a little bit. It's redundancy. It's backup. It's like having a spare tire in your car.
Right, yeah. Yeah, you're talking about kind of redundancy. Yeah. See, I understand what you're saying, but that's not exactly what I was talking about. If I could share my screen, Donny, just to help illustrate what I was talking about a little better. It's from
Sure, go ahead.
Biologos, and I know you have a bit of a bone to pick with them, but just to kind of illustrate my point more easily. All right. Let me know if you can see it. Okay.
I do see it, but I think once you started to share screen, you started getting a little laggy, but you're good now, Andrew, if you wanted to.
Oh, is my audio still okay?
No, you're good now. So it was just a temporary lag, but go ahead.
Oh,
Your
okay.
screen
Okay. Yeah. So this is kind of the thing I was talking about. Is there are different kinds of substitutions. So like from pyrimidines to purines, G to C, or A to T, etc. And obviously pyrimidines and purines, so like G and T and A and C, for example, have different chemical properties because they're different sizes, and the chemical properties go with them. So it's more likely that one nucleotide with one chemical fingerprint, let's just say, is more likely to mutate to the same fingerprint, chemically speaking, than to a different one. So for this is why these transitions, for example, where it's going from same to same, pyrimidine to pyrimidine, purine to purine, instead of one to a different one, is much more likely, and it's a higher frequency in the genomes of different animals, for example. And you can look at it kind of goes into a lot more detail, obviously, but let's see. Oh, here we go. Between different kinds of organisms, for example, and you see the same pattern, and that's what I was talking about with between transitions versus transversions, and how one's more common in the genome than the other. That's kind of one reason we're pretty confident that these are mutations, because they have that general pattern.
Well, wouldn't that be saying that you just kind of confirmed what we were saying, that if we're finding these mutations in the same region, you're saying, yeah, that should be expected. But that's what we said. We're saying, like, well, if we're finding these and they create a pattern evolutionarily the way that it is, and then you say, well, yeah, it's because the mutations are more, there's more percentages of this happening for that nucleotide going to this one, and it's like, well, I mean, that would explain the pattern then, wouldn't it? That would explain why it would seem as though
some of it, but that like the particular, I guess there are like more likelihood of one mutation than another, for example, but that's not a deterministic thing. That's not what you would need exactly for like a the mutational hotspot idea to work for these different regions, for example. Because the genome is so large that, yeah, of course you're going to have the same ones or similar mutations at some points, but that doesn't really help you here.
Okay, I'll go. I'll answer one more thing, and then we also have a couple other people. But I would say that when we look at the human population and when we see haplogroups arising, we notice that they're pretty infrequent, right? We don't have a lot of haplogroups. We just have the kind of a few letters of the entire alphabet for all different human beings over, let's say, 200,000 years, right? New haplogroups formed. And then we kind of don't see that much anymore because humans have expanded, right? So when we go over and we say, well, let's look at the mutations in chimpanzees, we find a lot more. We find a lot more, I don't think they named them haplogroups, I'm not sure, but we find a lot more mutations and a lot more substitutions in them over that amount of time. We'll just give it 200,000 years. But so what are we seeing though? We're seeing these mutations in these same regions, even though we're split and we're farther away from each other. We're still seeing these mutations come up, rise. They reach fixation in a population, and then there's that new mutation, and we can track like, oh, that's why they're Native American. They all have Q as a haplogroup. We can trace them. We can see that mutation reach the fixation. So if this was so improbable that it should be happening in chimpanzees and humans, but yet it is happening in them as well. And so it seems to me that there is, even though we're separated, that we're still accumulating mutations in these same regions, and they're still reaching fixations in the same regions that show like, okay, well, there must be some type of mechanism where these are how mutations occur in those species. So
yeah, I understand the point you're making. I feel like it's just kind of a matter of the size of the genome you're looking at and the likelihood of different mutations, how often they occur. So I'm sure if someone were to look at that and kind of all those factors together, that they would find a clearer answer for that. But yeah, I'll have to look into. That's an interesting point there. Yeah.
And Donny likes to do it, but with ERBs. So that's all him. On
right.
That
Yeah.
one.
Yeah.
I'm not.
Yeah. I've heard him talk about that. Yeah. So yeah.
Okay.
I'll have to do more research on that point. So
I would say,
in
in good discussion, gentlemen, we're definitely getting into the weeds when it comes to synonymous mutations versus non-synonymous and how common one type of mutation is versus another. But as you pointed out, or we pointed out earlier, Andrew, the fact that the synonymous mutations don't actually change the amino acid sequence. And so the codons can basically change. And, but what it reads to doesn't actually change. And so it doesn't really change the actual protein itself, but
right.
Your non-synonymous changes, they would change the amino acids and therefore have more of a consequence, would you say, to the organism rather than the synonymous mutations, because they're actually changing the amino acids?
Yeah, they're generally speaking, yeah, like obviously some synonymous mutations are going to have some impact, be it beneficial or negative. Like I know a few papers have, like I think with yeast, maybe. I don't know if that's been debunked by other papers lately. I'd have to look into that, but yeah, I know there have been, yeah.
Okay, so when
Sorry,
it comes to
I'm off on a tangent there.
No, that's fine. That's good. So basically, when you're pointing to these ratios, are you saying because of what occurs on a genetic level with these kinds of mutations, purifying selection should therefore favor synonymous changes more than non-synonymous, because the synonymous mutations don't actually change the amino acids, but the non-synonymous ones do, and so there should be a level of favor, in the ratios of these mutations, right?
Yeah, I kind of word it differently, but yeah, I generally agree with that. Yeah, there is a ratio you can use there.
Okay. So I think it definitely comes down to functionality, even in your degenerate codons, even in your, Dr. Herman Mays likes to look to statistical hierarchies when it comes to neutral variation, which I think is very similar to what we're talking about here. And I think it's going to come down to the two different starting points of the origin of all genetic variation, right? The evolutionists would say that the majority, or if not all, genetic variation is the result of mutations over time. The creationists would say that the majority, especially with autosomal DNA, is the result of created diversity, designed variation. But we do both agree that mutations happen. And I've got 3 references here to non-random mutations and hotspots. Speak to this a little bit. I find the evolutionists might be underestimating the amount of mutational hotspots that actually exist, just how non-random these mutational events are. I feel like they're underappreciating them. Speak to that a bit, Andrew.
So the idea of a mutation hotspot due to some chemical property or another, or just the epigenetic factors involved with it, is that the mutations in one region, or saying it differently, that there are probably going to be more mutations accumulating in one region, the hotspot in this case, than in a different region, a cold spot. I think what we might disagree with, though, is the number of mutations there might be increasing. It may be a higher rate of mutations happening in that particular region, but the mutations are still probabilistic. Like they're not gonna. There are. That's why I don't like the word random as much, and others have spoken to this, because as we've been discussing, there are some statistical likelihoods or biases with one mutation versus another, but they're not deterministic, which is what you would need for a specific set of mutations to occur in a specific region, because again, the genome is so vast and so large, even with the timescales that we're talking about in terms of evolution, that the likelihood that even those biases would account for the same order here is kind of remote.
Firstly, when it comes to mutations, I would argue that from a design perspective, especially from the design diversity perspective, and starting with theology, God, he knows the future. He has divine foreknowledge. And so he knows what's going to happen after creation. He knows what's going to happen after the fall. He knows the various environmental changes that are going to take place. He knows what's going to happen after the flood and the flood bottleneck and the shifts in environments. And so I would argue that a lot of the mutations that are accumulating, they are in more ways deterministic than the evolutionists would say. And so I think God designed ATCG. I think he's designed certain spots in the genome, certain letters to change or mutate more frequently. I mean, just one mutation in coat color in a bear can result in what we see with a polar bear. And so it looks like it's been a big change, right, in its environment, but it's actually due to a mutation. It's due to a point mutation, something that's deleterious, but there was a benefit in terms of the environment. And so I think a lot of this is the result of divine foreknowledge and some determinism at play in the sense of mutations. Go ahead and speak to that a little, Andrew.
Yeah. So I guess one point, and then I do have one more question if you want to wrap this up soon.
Sure.
Would be, it seems like at that point, which I don't disagree with that possibility, because obviously God can do whatever he wants, or any other kind of deity or supernatural intervention can occur. But I think at that point, we're not in the realm of scientific inquiry anymore. And so we can't really investigate it by scientific means. So I would just say that, I guess my question is, since you accept mutations do occur, but created diversity is also a thing according to your model, how would you kind of distinguish between the two? If you were kind of given one side by side, could you tell the difference?
Yeah, that's a good question. I could answer that a number of ways. The first point I want to say is I do believe that there is a level of predictability with what I'm saying. And that would come down to forward-thinking mechanisms. And so if what I'm saying is true, that a lot of these changes point back to a forward thinker, then we could study the changes. We can study a little bit more deeply as to which mutations are non-random, which ones are more random. We could look to epigenetics, basically, where environment can dictate which genes are turned on, which genes are turned off. So in a nutshell, yeah, I think we could predict that when we study the genotypes of the organisms that are experiencing a lot of these mutations and these changes, we could study to see if these are happening by chance or if there seems to be some directedness going on in the genome. You could respond to that in a second, but your second question, but I would say this for disclaimer, the patterns we're talking about here, the nested hierarchical patterns, even when it comes to the so-called neutral changes like third position codon changes, I do believe that they're there for functional reasons. And I do believe, like, for example, this paper here, which I know you're familiar with, redundancy of the genetic code enables translational pausing. And so it looks like rather than these sequences just being able to tolerate error, because I do believe there's a lot of front-loaded redundancy and also over-design in the genome. And so, like, for example, an engineer, when he builds when a group of engineers build a bridge, they don't build it to they don't build it in a way that holds the exact amount of cars that should hold it, right? They over design it. So if it's supposed to hold 1,000 cars, they'll design it to hold 10,000 cars, right? That's good. That's good forward thinking. And so I think we see a lot of that in the genome. And so just because a region is not conserved does not mean that it's non-functional, or just because it seems to have a neutral change doesn't mean that it's also not functioning in terms of, and what this paper goes into is the dual functional nature of a lot of the code, where you do have these degenerate codons that tolerate error. So they're redundant. That's good. But they also help. Yeah, there's information flow going on. The redundant elements help to slow and speed processes in the cell. And so there's a lot of multifunctionality going on. And I think Matt would agree that we would predict for a lot of these sequences and a lot of these patterns, the reason why we're seeing them is because there's not only one function, there's multiple functions going on, kind of like we see in protein moonlighting, where you have these nuclear DNA proteins that function not in one way, but in multiple ways. I said a lot there. There's one more question I have to answer that you asked, but to be fair, if there's anything you'd like to respond
yeah,
to,
that's okay. I can't even remember the second question I asked. Anyway.
I think it was basically, I think your question was, how can I differentiate between that which is design diversity and then that which is mutation related?
Yeah, that's right. Yeah. I guess before you answer that,
I said a lot.
The only thing I would say is probably we would disagree on the how to put this, the significance or commonness, I guess, of this this codon bias is what you're talking about in terms of different lineages, because when you look into it, for example, vertebrates or most vertebrates, since they generally, compared to something like a fruit fly or bacteria, have very small population sizes, selection isn't as efficient. So that way you tend to see more of this selection for certain codon biases in bacteria or Drosophila compared to vertebrates, for example. So I would say it's not a one or all thing. So it has to be compared between different organisms, so that might affect it. And yeah, I guess that'd be the main point I'd make there, is it's not a generalization that's that easy to make.
Oh yeah, that's why I think Dr. John Sanford actually, with the genetic entropy, he doesn't really focus on bacteria and mosquitoes and fruit flies and things like that, because their mutation is a little bit different. So he looks at more like the humans. So when you wanted to create and look at the genome, he mapped what he would consider Eve's sequence based on a genome without mutations. And as you know, Dr. John Sanford, his entire life has been basically gene sequencing. He invented the first stages of genetic manipulation with plants, and the first GMO plant gene gun. So I would imagine he did a pretty good job at being able to identify what was a mutation and not. He has a whole paper on it, actually.
Well, Matt, how would you, so in a nutshell, when it comes, and it's a great question that Andrew asks, how can we tell the difference between that which is the result of created heterozygosity? Heterozygosity means a state of DNA diversity, essentially, and that which is mutation related. A quick answer is we would look at allele frequencies. We could look to alleles that are very common, where basically everybody on the planet has them. They're some kind of benefit to humans or whatever organism we're looking at. They're not disease causing. We could confidently say that they are, because they have a very high frequency, right? And so we could say that they're created. Alleles that are rare, they exist at very low frequencies. Let's say blue eyes, for example, we would say are most likely the result of mutations. So the real short answer is allele frequencies. But a lot goes into that. I wonder if Matt would have roughly the same answer if he wanted to elaborate. And then, Andrew, let's throw it back to you to critique our response.
Yeah, and that's also a good way we can actually determine whether or not the junk DNA has any function at all. Is the body supplying ATP to these regions? If it is, then it probably has a function. Another good way would be if it mutates, what region of the body does it affect? For example, if the CO1 gene, if you don't think it's doing much other than respiratory reactions, but then you get a mutation in there and it makes you go blind, then you know that there's a secondary function that has to do with your eyes. So I think that we're still learning so much about the genome that it's quite amazing. I like it.
Andrew, go ahead. Take your time.
Yeah, I guess the only thing, that's an interesting point there. I guess the only thing I would say is in terms of alleles and the kind of translational speed you're talking about with regard to synonymous codons or synonymous mutations specifically. It seems like, based on my understanding at least, that would affect cellular processes, of course, but I don't necessarily know if that would result in different alleles per se, because the alleles come from, I guess it does go into the nuts and bolts of what you want to define as an allele or not, whether you want to call regulatory portions of the DNA alleles or not. But yeah, I guess that be what I have to say there. I hope that's my point there is a little clear.
I think the bigger picture, and you're more than familiar with the ENCODE project, and if you'd like to say this is something specific to that too, Matt, feel free to do so. But I want, especially for the audience sake, is the bigger picture is it comes down to function. And I would say because the evolutionary model basically believes that everything is a process of descent with modification, and just millions of years of evolutionary history with precursor ancestors, so on and so forth, which means we should find in the genome a lot of genetic mistakes, as you've pointed to, right? Pseudogene. So there's a debate there. We should find the ancient remnants of viral infections, ancient invasions of parasitic DNA, basically. That's where we get into allele discussion, allele sequences, or ERVs, so on and so forth. We'd also expect just to find a lot of evolutionary leftovers and a lot of non-functionality going on in the genome. We should not only find, if evolution is true, we should not only find nested hierarchical patterns in the biological world within the functional sequences, but we should also find nested hierarchical patterns within the biological world in the non-functional regions. And so the question to the common design proponent is, why do we find nested hierarchical patterns and distributions in sections of the genome that aren't functional? And that's what you'd expect if evolution was true. If it's descent by design, or if it's nested hierarchies by design rather than descent, then we would expect a lot of functionality. So we would find these nested hierarchical patterns within so-called non-functional regions and non-functional elements. We'd actually find those to reflect just that, which is function. And so the one thing I want to say is, in terms of the bigger picture, we understand very little of the DNA language. We're learning so much. The ENCODE project discovered a lot of activity Yes, the activity doesn't necessarily equate 100% to function, but that's why I think it's so important to study the various interactions between the systems of the cell. Because yes, we find a lot of activity, but we need to look at specific interactions. We need to look at transcription factor binding. We need to look to protein binding to DNA, histone binding, histone modification, three-dimensional interactions within the cell. And so a lot of this has been looked at, and specifically in the ENCODE project and subsequent projects as well. And we actually do find a lot of interactions taking place, and a lot of these interactions actually do have outcomes and consequences to the function of the cell. And so I think that that would tell us that the majority of the genome is functional. But again, a lot of this is dependent upon whether the activity and the interactions going on is significant function. And so, Andrew, respond to that. But my whole point is the bigger debate question is going to come down to, and I believe it does come down to, function. And that includes the pseudogenes you're talking about, even the ones that don't produce RNA or have a missing promoter. That includes the ERVs that are transcriptionally silent that have been discussed. And the Grayson has pointed to that. And also the so-called third position codon degeneration. So anyways, I said a lot there. Speak to that a little bit. Tell me if you agree with my bigger picture assessment, and then we'll kind of go from there.
Wait, hold on, Andrew. Don't lose your thought. Hold that thought. Donny, I just wanted to acknowledge there's a few other people here waiting to have a word or two. I'm not sure if I just don't want those guys to get forgotten about. So
sure,
been patiently waiting on. So, all right,
Andrew, go ahead. And then if anybody had any thoughts or points they wanted to make too on the topic of evidence for evolution, feel free to just jump in. Consider it a free for all now.
Yeah, I guess the last thing I want to say, and I don't want to take up too much of the limelight, so I appreciate the time you've given me. I think it was someone in side chat, Jim Vaughn, I think. I just want to clarify what I said, because he in one of his comments he asked what I meant exactly when I was talking about selection and single-celled organisms. If it would be possible for you to highlight that comment, Donny, if you can find it.
Who was the one who said it, Andrew?
Jim Vaughn, I think.
Jim Vaughn.
It was a relatively recent comment. I just want to clarify what I meant exactly.
There's that one. Oh, this one right here. Did I hear Andrew correctly in simply organism selection is limited? If that is the case, how can it account for the complex organism and its more diverse selection?
Yeah, so just to clarify that, and this will be the last point I'll make. What I meant was, for a kind of simplistic example, say you have two populations of different organisms, and one's 1,000 individuals, and another's 1,000,000 individuals. Say the million in this case, and the numbers of course are much higher, but the million in this case, that population represents some bacterium, and the 1,000 in this case represents, let's say, a fish or another vertebrate of some kind. What I was talking about was in the population of 1,000,000, 1,000,000 bacteria, for example, selection's more precise. Let's just say it can select for against more specific traits or more the detail basically, and that includes things like how synonymous codon or synonymous mutations affect translational speed, for example. So that's what I was talking about, is in terms of population size and the synonymous mutations specifically, not selection everywhere, if that makes sense. I hope that kind of clears things up.
Yes. Thank you, Andrew. Any thoughts from anybody else on the panel or any questions? Evidence of Christ, you've been very patient down there in the bottom left-hand corner. So if you'd like to say anything, brother, good to have you.
I would if I was good at genetics, but I can't really chime in on all this.
No worries.
Oh, I think Brock.
Can y'all hear me?
Yeah. Oh, yeah. Yeah, we can hear you. Brock had his hand raised if he wanted to say anything, and then we'll throw it to Professing Preterist. Or Brock, you have to unmute. Let me see if I can do it from your end. Okay,
Can
you're
you hear
good to
me?
go, Brock. Yep.
Can I bring up the old topic from earlier about radiometric dating? Y'all don't
Sure,
mind?
sure.
So I'm not an expert on this, and it's not like I 100% believe it all, but I wanted to tell Ken Tobin about this, but he's gone now. And so I guess I'll aim at you, Donnie. I guess
Sure.
I want to know what you think about this. So I wrote it down on a little doc or something. Radiometric dating might be a good way to see how old something is, but I'm not sure. I think that stuff like chemicals will go away over time at a certain rate, and the less of it the rock or something has, and the older it is, but I don't remember everything, so I could be wrong. It might not work that way, but there might be a limit to how much stuff or chemicals or whatever that it can have, like rock or something. So if a new rock is formed naturally, then it starts out with a set amount of chemicals, and then they will decay at a certain rate over time. Is that how that is supposed to work?
That's
well,
Matt, go ahead. Yeah.
Good
This
question.
is your specialty, Matt. Take it away, brother.
All right. So essentially what happened is during the Big Bang, lots of different elements were formed, but that wasn't the end of their formation. For example, most of the radioactive elements that are on Earth supposedly came from a supernova event. It was a very strong, powerful event that created super heavy elements that decayed into the radioactive elements that we find on Earth today. We've recreated this in a lab with cold fusion, where we've created super heavy elements that rapidly decay and form into the elements that we have on the Earth today. We formed them, not just radioactive ones, but we formed the normal ones that we see in the proportions that are on Earth as well. But we've also created a couple radioactive ones. Now, I can't get the lab in Ukraine to give me any information on the uranium, probably because people use nuclear warheads. And so I can't get that information from them. But I can get other information, and you can find it as well. And this is the most unique thing of all when it comes to radioactive elements. And this answers the question of how old the Earth actually is. Because when they form something like potassium, you need to ask yourself, in what proportions does it form in, and what are the ratios of the parent to the daughter isotope? Because when you want to date something, you need to look at the daughter isotope and say, well, how many are there? How much is there? Well, if there's that much, then it must have decayed from the parent isotope. So Kent used the analogy of a candle that was burning and you came in the room and found it. Well, how much had it been burning already? Well, now we can answer that question. And we've never been able to do this before because we've never had a laboratory that used a Z-pinch and struck something and created these elements. Now we have. And they're mostly using it to look at radioactive elements that have an extremely fast half-life within days or minutes. And they're selling it to medical laboratories. But they've also done it with other radioactive elements. And one of those is potassium. Now, here's the amazing thing. When you look at the potassium ratios to parent to daughter, they form with both parent and daughter. So that means they're not forming with just parent isotopes with no daughter, which would literally means millions of years would have needed to pass before any daughter elements formed. What we found is parent and daughter formed like they are on Earth today at exactly the same time. So that means that Earth can't even be 1.25 billion years old, because if it was, then the potassium that formed in front of our eyes today would have actually looked like it would have billions of years ago, right? But it doesn't. It forms like it looks today. So therefore, radioactive dating, to me, is evidence for young Earth creation. And that's why I like using radiometric dating now. So it's actually great evidence for young Earth creation because it kind of refutes the deep time scenario. And then you can look at the lead paradox. There's more radiogenic lead than there should be. So this paradox was tried to be resolved through saying that, well, Earth must have a non-radiogenic core. But the only way that's possible is that if Earth formed only 100 million years after the Big Bang. So that would make Earth 13.9 billion years old. So you can't have one or the other. So the only rational way to solve it would be look at an experiment. Does lead actually form with radioactive isotope daughter elements? And it does, just like the experiment shows. So I think this is great evidence for young Earth creation. Unfortunately, we can't determine whether or not it's just 6,000 years old or 10,000, because when we form argon, it's a gas and it forms in these weird proportions like carbon does. So we can only look at the actual heavy minerals that form. So I hope that makes sense. If it doesn't, I'm having a debate on that very topic next week and I'm coming with slides, images, pictures, everything. So,
when will that debate be again?
On the 16th on Standing for Truth here, this channel.
16th of June.
Yeah, not against him though, but yeah.
I know. I clicked that one because I was like, oh man, I don't have the Matt versus Grayson thumbnail here in the studio. So, but you can see it on the channel. That's this week, right, Matt?
It is. It is. It's
This
coming up.
Saturday.
So I guess I really got to get my pictures ready to go.
And for anybody who loves the topic of radiometric dating, we're doing something similar to what we usually do with these big topics like ERVs and chromosome 2. So I did a series of debates on those. And I think debates are great peer review, I guess you could say, where our critics are a huge benefit to us because we can engage in debates as we're writing a book or putting together lectures and presentations, and therefore we can see what the critics are saying. And so an important aspect of young earth creation, and also what we do here at Team SFT, is we want to be fully up to date with what the critics are saying. And so we'll engage in formal debates, and that'll help us, I guess you could say, leave no stone unturned in the books that we're writing. And so Matt, he's got a book that will release after his upcoming debates. But then Matt, you'll also be doing some very comprehensive lectures and presentations on this channel too. And so we're going to leave no stone unturned on the topic of dating methods. Brock, did you have a follow-up, brother?
There was one other thing I wanted to mention. Actually, two things. So when Ken Tovin said that it doesn't matter how we name animals, I disagree because it just helps us understand them better. You know what I'm saying? I just think it's how it works. Also, a while back, I heard him say that evolution was stupid, and it made me think of this episode of SpongeBob where Patrick's like, maybe it's stupid, but it's also dumb. You ever hear that one?
It's a little of both, isn't it? Yeah, I think what Kent was saying, it can be good, it can be bad. So Sam and Matt, I wonder what you think about this. You do have your Linnaean taxonomy, right? Kingdom, phylum, class, order, family, genus, species. And then we categorize animals based. You see, the thing is, though, they'll oftentimes reclassify, or they'll classify, make a new species out of something very trivial. And we see that in the field of paleoanthropology, where you have two groups of people, lumpers and splitters. And so you have some paleoanthropologists that lump a lot of what's called different species based on differences in morphology and so on, and they'll throw it into one category. As creationists, I think we're more so lumpers, right? Because we would put, let's say with canids, you've got your wolves, your domestic dogs, coyotes, dingoes. We put those all into one group or one kind, the dog kind. When it comes to humans, we would say Neanderthals, the Hobbit, right? Floresiensis, Naledi, Erectus, Homo sapiens. We would say that they are all one group, not different species, all one group called human, all one kind called the human kind. But a lot of paleoanthropologists that are splitters, they'll find one little difference, let's say in morphology within Neanderthals, and they'll say Neanderthals are now a different species. They've split the group up into different species, when in fact they're not different species. They're the same species. They can interbreed. We literally have the genetics of Neanderthals. And so, yes, there's good and bad, but there's probably more bad because there's more species than there should be, because they're just naming different creatures based on trivial differences. Matt, Sam, what do you think, brothers?
Hold on. And speaking of the naming and all that, you ever heard of convergent evolution?
Yeah.
To me, that alone would debunk the idea that we can use like similarities and differences to see how closely related something is. Like, that's how I feel. Does that make sense?
Oh yeah. Because if something is it looks the same but it functions different, they just say, well, it's just convergent evolution. It's just very convenient because they're missing those in the fossil record, right? They're just fossils everywhere.
Yeah, so so like, let's say there's like a coyote and a thylacine. You ever heard of that? The thylacine with the stripes on it, the Tasmanian tiger?
Yeah, they're dead, extinct. Yeah.
Sadly, they are, and they shouldn't be, but that's what happened. And that sucks. Well, according to evolutionists, one is a marsupial and one's a placental, so they're very distantly related.
Right.
So, but by that logic, I mean, you can't really use their similarities and differences to see how closely related they are. Maybe we could use genetics. I don't know. I'm not a geneticist. But we can't use like their similarities and differences.
Right. Well, Baraminology tries to. What they do is they take the skull, and then they'll look at a cat's skull, and then they'll look at every cat species on Earth, and they'll map the differences. And then if they find something that looks similar to a cat, they'll line it up with what they have, and they'll say, no, it's a totally different kind. Right. So that's how they pull things in and out of different kinds. Like cats are almost identical, and they arise out of nowhere. They're called the ghost lineage because they just appear in the fossil record fully formed like a tiger or a lion. And that's it. The lion just forms out of nowhere. But cats are so genetically related. Go ahead.
So I'm not saying I believe in God, but what you said makes evolution sound suspicious because they just appear like, oh, almost like something created them.
Yes, yeah. Look up ghost lineage. They're everywhere. Cats are.
I've heard about the Cambrian explosion. That's like an example of that, right? It's just all these like bug things, the normal Acaris and the little fishies, and they're there now.
Yeah,
almost like they were created.
Well, Stephen Jay Gould pointed that out. He said that they find stasis in the geological column. He said it's a problem. They didn't find any transitions. So he said that this evolution had to take place really fast. He's just rescuing what Darwin had predicted because it's not what they found. But they have a worldview, and they have to protect that worldview. So they're forced to interpret the data only one way, regardless of what they find.
May I have a word on that?
Who's this? I didn't see him.
Go ahead.
Hi there.
Go ahead, brother.
So Stephen Jay Gould advocated.
Actually, Dr. Dino, before you do, I just want to introduce you. So I appreciate you being here.
Oh, sure.
I got your email. And so, yes, it's always great to have a new evolutionist. I know you evolutionists don't really like being called evolutionists, but for sake of a better word, we'll definitely set you up with some debates. I think that'd be awesome. We could set you up with Kent, myself, T-Rock, David McQueen. So I appreciate you joining this after show. Feel free to respond to anything that you'd like to or bring up any arguments we can engage. Before you do, Patty Smith, $10 super chat. Thank you very much for your support. Before I forget, so Patty Smith says a few weeks ago, Dr. James Tour, yes, he debated Professor Dave. Great debate. If you haven't seen it, check it out. Definitely an entertaining one. And Patty says, would love to see a video with Dr. Rob Stadler evaluating this. We did a video probably going back 3 years ago now with Dr. Rob Stadler critiquing Professor Dave. Me, Matt, John Maddox, Rob Stadler. And that debate is doing really good, or that video is doing really good. I think it's at like 15 or 16,000 views. And so point is, yes, we'd love to have Rob Stadler on to evaluate that debate. Okay, anyways, Dr. Dino, spelled a little differently. There you go. Introduce yourself briefly and then provide some of your comments.
Sure. Well, first, thank you, Donny. That was very nice. I'm Dr. Dino. I just really started on YouTube, but I'm interested in teaching people about various scientific topics such as geology, evolution, things like that. And I guess really quick to redefine living. Stephen Jay Gould advocated for a model of evolution called punctuated equilibrium. And I think you got it a little off. So what he advocated for was there would be, say, a sudden shift in an organism's environment. It would evolve to accommodate that shift, and then it would be well suited for that environment, so it wouldn't change very much for a long time. That was his model, rather than Darwin's initial gradualism, where things just slowly
Why did he
change.
put that forth? Why did he put that forth?
So he put that forth because there are some lineages, like horses, I'm pretty sure he worked with horses, where we see them have a sudden change, like, say, longer limbs to be better runners, and they don't change for a while because they don't really have the pressure to until their predators are able to catch them more and more often. So then they have another jump to get away and stuff like that. It's not a refutation of evolution.
So what you're saying is, you're confirming what I said, that because they did not find these transitions in the geological column, he created a rescue hypothesis called punctuated equilibrium, to account for the lack of transitional fossils. Just
No,
what I said.
no, it's not.
So that's what happened.
It's not a rescue for transitional fossils. We have transitional fossils for horses. It's just like, say, we have one species that lasts for 2 million years, and then we have an abrupt change to a new species that lasts for 3 million years.
Can you tell me
species doesn't change much?
Can you tell me the empirical methodology for establishing ancestral relations with mineralized fossils?
With mineralized fossils, so it can be a bit difficult. If we don't have DNA to work with, we mostly have to rely on morphology. Now,
So you don't have
I
an
should
empirical.
specify, morphology isn't just how something looks. By looking at the bones of something, we can tell how it formed those. And
excuse me. I'm just looking to know if there is an empirical method, because if not, then you're just putting forth conjecture, right?
Well, it is generally based on morphology with fossil organisms.
Right.
That is
you
one of the
line
best methods.
something up in a certain way based on similarities, but without any empirical methodology.
No, we can definitely define it empirically. What's usually done is something called a character analysis. It's a somewhat complicated method, but we can do it empirically.
So I asked, what is that empirical methodology for establishing those ancestral relationships with mineralized fossils? Because earlier you said that there wasn't, it was morphology. But now you're saying something different.
No, morphology is the method that we usually use.
That's not empirical, sir.
We identify the morphological characteristics using a character set, which we then use to. Sorry, it's late for me. We use
That's not an empirical. That's not an empirical method, though.
We can distill it into an empirical method. If you want, I can try to find a link to an explanation. I don't think I can provide one right now.
So, question, Dr. Dino.
Sure.
Maybe I can ask you. I was going to ask the other guy. So, I think a little bit of a problem that you have, though, with your theory of evolution comes in with the water bear, where this is an organism that can survive anywhere, anytime, any kind of environment. So it has no pressure, as you would put it, to evolve. Yet that would mean that it's on the slowest time scale of evolution, but they've found that any kind of quote-unquote mutation that would occur due to evolution only goes back so many generations of these species that the Earth cannot be longer or older than about 6,000 years old.
So for water bears, I assume you're talking about tardigrades, right?
Yeah, tardigrade, yeah.
Okay. Well, something can happen if a population doesn't have a pressure to evolve. That also means that they are free to diversify. Like, they're free to have a variety of mutations that don't really change their fitness in their environment too much. So you can have a wide variety start to appear. They continue to interbreed and pass along that variety.
So, but what I don't understand about that then is, doesn't that mean that if they were on the longest scale of evolution, because they have no pressure to evolve, that like it would have to account for these millions or billions, however long Earth people, however old people think Earth is, wouldn't have to account for that, because there's a set rule set of evolution is based on X amount of time because of just the way that supposedly genes and DNA works.
It would depend on a few things. Depend on things like their genome size, their mutation rates. Can depend on a variety of factors. It's certainly possible that they could rework most of their genome given enough time.
Well, so then wouldn't everything?
That said,
just be
I haven't
reworking its
read any
genome?
papers on this topic. I don't know the study you're referring to. I'm sorry.
Yeah, that's okay. So I just because I'm taking that same logic, and it's like, okay, well, wouldn't everything then just be resetting its genome over enough
Yeah, no,
time?
you're
Given enough
absolutely right,
time,
because
maybe.
you're absolutely right, because they on one hand they want to say that it's an unguided random process that's always occurring through generations, and because things are always reproducing, they're always accumulating these mutations, and those mutations are the driving force of evolution. The problem with that is that when we observe that there is no change, like we have examples of living fossils or ferns that we have found to be what they would say are the oldest living things, there isn't change. That's why they're identifiable. A perfect example of this would be mosquitoes found in sap, preserved over these long ages of time. And how do we identify them? Well, because they're identical to the way they look today. So, when it's convenient for them, they'll make up something and suggest that they haven't changed at all. But you're right that it does contradict their model, where things are always reproducing and they're always accumulating mutations, and these mutations are the driving force for this change.
Yeah,
not necessarily. Not necessarily. Like, just because we have a lineage of mosquitoes that look like ancient mosquitoes doesn't mean that ancient lineage hasn't diversified into a multitude of lineages. We just happen to have a lineage today that resembles the ancient mosquito.
Right. That's
So
why
by
I
that
said
logic-
conveniently.
Sorry.
When I said when you find something that contradicts your model, you conveniently have a way to rescue it. And that's what
you
you've
assume
done.
it's a
But
contradiction.
unfortunately, the problem is when we understand your model, that these mutations accumulate through generations, and over these deep ages of time, these things are always going to be picking up mutations. That change is unavoidable.
Yeah, and it almost comes down to two. It's like, okay, so you're saying, well, just because there are mosquitoes found in sap that look like mosquitoes we have today, doesn't mean that there is wildly different mosquitoes. But what that would have to insinuate is that then there would be like mosquitoes were selectively breeding themselves in order to have different variations of them. Like, because, for example, did mosquitoes get bigger over time? No, they got smaller over time, right? That's the whole theory of dinosaurs, Dr. Dino. That a T-Rex got smaller over time and is now a chicken. It makes no sense.
No, that's not true. T-Rex did not evolve into a chicken. Although that is related to a question I did want to ask when I came in here.
Actually, if I could,
Hold
before
on.
you ask. Okay, good. Go ahead. Yeah, if you guys wanted to wrap up that topic.
Oh no, I don't want to. I didn't want to deviate from this topic, because I think that we need to talk about the nature of these mutations.
Yeah, absolutely. I think it's important to know,
That,
because
that is the driving force of evolution. So
Right.
if it is the case that these mutations have a negative effect, meaning that they're even slightly deleterious, then those mutations are going to accumulate also over time.
And kind of to the point with that too, just to draw an allusion to that, it's the same way that an atheist would say, well, bad things happen, therefore God cannot be real. And evolution is saying, well, sometimes things happen, and that's why there's variations that can't be accounted for.
Well, but you're assuming that what you said before about deleterious mutations accumulating, you're assuming that there's no mechanism for removing individuals that have more deleterious mutations from the population.
Well, let me touch on that real quick. That's a good point. And so I would argue when it comes to the entire fossil record, okay, if we're looking at fossils in the ground, for the most part, they don't have DNA, they don't have genetics. And so the theory is only going to be as good as what the empirical evidence suggests. And so the evolutionists would argue that mutations and natural selection, the driving force of evolutionary change. Well, here on the screen, you can see world famous evolutionary population geneticist Michael Lynch, Kitely, so on and so forth. Okay, there's Kondrashov. He's written a lot on this. And so they point out that the vast majority of mutations are deleterious. This is one of the most well-established principles of evolutionary genetics, supported by both molecular and quantitative genetic data. So you can go to other quotes too, where they point out that. Notice here, Iyer, Walker, and Keatley. It seems unlikely that any mutation is truly neutral in the sense that it has no effect on fitness. All mutations must have some effect, even if that effect is vanishingly small. So I would argue that the mutation rate's too high. The vast majority of mutations are deleterious, but they're only slightly deleterious, which makes them nearly neutral or effectively neutral. Why it's called that is because, again, they're slightly deleterious, but natural selection can't see them. And because natural selection can't see them, natural selection can't remove them from the equation. And so they become subject to what's called genetic drift. And so basically these mutations in humans, the mutation rate, I can hear somebody's, a lot of background noise, someone's chair, if they could mute possibly. Brock, it might be you, my good brother, if you could click the mute button. And so the human mutation rate is quite high. It's about 100 new mutations per person per generation, with most of those being slightly deleterious and nearly neutral. And so I would argue that mutation accumulation actually puts shelf lives on genomes, which means if you want to look to the fossil record, well, the fact that mutations today put shelf lives on genomes and species can't persist for millions of years into the future, they definitely could not have persisted from millions of years into the past. And so my question to Dr. Dino would be, what type of mechanism can you present us that will rid the population of so many of these deleterious mutations pouring in generation after generation? Go ahead.
All right. To be honest, I would like a chance to analyze these sources myself.
Sure.
And maybe compile a few of my own before providing an opinion. I am not a geneticist. I am a paleontologist, mostly focusing on morphology. So this is not my specific field, so I do not think I'm equipped to give an accurate opinion.
And that's good. Sam, let me say that. Let me say that, and then you go. Because what I see a lot from paleontologists, paleoanthropologists, and basically these historical constructions based on the fossil record is they are essentially building or making these historical reconstructions, but they're not actually answering the problem that we have today of mutation accumulation and the so-called driving forces of evolutionary change. And so those historical reconstructions are just that. And there's a lot of inference involved. And so I really do believe it comes down to this kind of change through mutations. If it actually degrades rather than promote forward evolution, then those historical reconstructions can't really be considered empirical. But I do appreciate your willingness to look into this, Dr. Dino.
Even if the genetics are degrading from generation to generation, if that's the case, that doesn't take out all the other evidence we have for the Earth being old, and we do have quite a bit.
So
okay, Sam, go ahead, brother. Yeah, go ahead.
Well, I would just wanted to make sure that you understand the problem is that we're looking for a mechanism that would remove the mutations that are not selected.
Well, they would. I would guess they would mostly just be carried along, especially if they're not immediately deleterious.
Okay, so the problem becomes without that mechanism, and it doesn't exist, by the way, or at least as of this point, there isn't one. Okay, the problem then becomes that if it is the case that the genome is going the wrong way, I mean, would you understand that would be inconsistent with a Darwinian type of upward change, right? If it's the case that the genome is degrading, it just follows. It makes sense that if you're starting with a perfect genome, it would degrade over time. If you have a degrading,
you are assuming we're starting with the perfect genome, though.
If you have a degrading genome, it's pointing one direction.
And let me point that out. You can use, there's very sophisticated, Sam knows about this, you could touch on this too. There's very sophisticated evolution modeling programs. One is called Mendel's Accountant, and the results have been published in both creationist journals, but also secular journals. And you can start with a population with no mutations. You could start with a population with many mutations. And so it doesn't have to start with a created genome of no mutations, although that's what we'd assume from the biblical model. You don't have to start with that in these modeling programs. And regardless of what you integrate into the program, whether it's a lot of selection, a little bit of selection, a lot of beneficial mutations, just a few beneficial mutations, the program always demonstrates that genetic degeneration is inevitable. And so there's various mechanisms like synergistic epistasis, a mutation count mechanism, truncation selection. They've been proposed, but they've been looked at, and they simply don't work because, as you've noticed, Dr. Dino, is they're slightly deleterious, and so they do just spread. And so by the time they spread enough to where they become noticeable, they've already spread into every single individual.
Well,
and so
mutations
go ahead.
can be deleterious, and they can be beneficial, and they can be neutral. It all depends on the context that they're within. Something that's deleterious in one situation could be beneficial in another. It's highly variable.
But remember, they've looked at this. So they've assumed, okay, for sake of argument, let's say there are some even super beneficial mutations. It still doesn't counterbalance the damage. But even if you look to, like if we wanted to look to very specific so-called beneficial mutations, when you look under the hood, I like to say, right, let's look to the genotype rather than the phenotype. And what you find is it's typically reductive. There's something breaking down. There's some kind of loss there. And so that's never going to counterbalance the damage due to the influx of these deleterious mutations just pouring in to populations generation after generation. And notice on the slide here, Dr. Dino, this is right from your own literature, Michael Lynch, world famous population.
I would have to read that literature before confirming that.
Yeah, no problem.
Like I get what you're saying, but I would have to read it myself.
I do
but
have
that said, I do have to get going soon. May I ask the question I came on to ask really quick?
Yes. Yeah, go ahead.
Okay.
Ask your question.
Just to everyone on the panel, are birds dinosaurs?
No.
That's a good question.
Yeah, no, I
don't know.
think it depends on the, like you're talking about context, the context of that question. When you use the word dinosaur, that's a fairly new word. So are you referring to a dinosaur in the context of an animal that lived millions and millions of years ago? If that's what you mean by it, then I'm going to say no. But if you're referring to an animal from a gene pool that existed thousands of years ago, and maybe a lineage, a type of lineage that derived from that, then it's possible.
Okay, maybe to explain, I'm referring to the specific group of archosaur reptiles that we refer to as dinosaurs, and I'm asking if birds are a part of that group.
I would say no.
If birds are reptiles now?
If birds are a part of the dinosaur group, which is
Are you asking if birds are a subset of the greater archosaur group?
Yes.
I would argue that based on taxonomy, kingdom, phylum, class, order, family, genus, species, every single creature on the planet has to be more similar to another creature. It just turns out that humans are most similar to the great apes and primates. And so a taxonomist, correct me if I'm wrong, would classify for various reasons, looking at physiology and looking at morphology and anatomy and so on, they would classify humans as a human great ape and chimpanzees as a non-human great ape. And so birds,
yes.
Right. And so birds are most similar to your theropod dinosaurs. And based on the arrangement of their hip bones, I believe is a major way that they classify your dinosaurs. And so birds today would be most similar to something like a theropod dinosaur. But I think that all comes down to taxonomy. which is oftentimes arbitrary. It's subjective.
Conjecture, yeah.
So I wouldn't say that they are dinosaurs, but if you're going to look to taxonomy, I would agree that birds today are most similar to theropod-like dinosaurs. Does that make sense, Dr. Dino? And feel free to speak to that.
I think so. And so just from my point of view, I believe that birds are dinosaurs, both anatomically and by descent. I believe that they are dinosaurs. There's an entire suite of anatomical characteristics that are shared between many dinosaurs and most, if not all, modern bird species. For example, feathers, hollow bones, three-toed feet with a little dew claw hanging up. There's a lot of characteristics.
How would you delineate your interpretation of the data from a biblical interpretation of the data? And how would you delineate your interpretation and make it unique to your model? Because if it's a neutral line of evidence, if it's something that can be explained by both models, then you haven't supported your position in any way.
There is no Bible in the bones. I have no need for a biblical hypothesis.
Let me address that really quick. Do you understand what a worldview is?
I believe I do.
Yeah, it's your philosophy, your presuppositions by which you filter this data that you're looking at and by which you interpret it. So when you say there's no Bible in the bones, that would be true because you're coming from a non-biblical worldview, and that's the way that you're interpreting the data. But that doesn't answer my question. You would be begging the question with that response.
I failed to see how. I am
Because
simply going off of their. I'm
you
just
are only
going off of their
assuming-
anatomy. I'm not assuming
you would
anything. I'm
be-
going off of visible things within their anatomy.
Yeah, so
That's
you
what
would
I
be
made my
assuming.
conclusion on.
Sorry, I thought you were done talking. You would be assuming your position instead of arguing for it. So I'm asking you for a line of evidence that isn't neutral, lines of evidence that can't be both interpreted from within the biblical worldview and the non-biblical worldview. And so far, you've not given that. You're
I'm
just
not
saying
quite
that
sure
you have
what
a
you're
way in
asking
which you interpret the data. Okay, so what?
Just what are you asking me to show you?
A line of evidence that's biased, a line of evidence that supports your position that's inconsistent with ours.
Yeah,
My
basically,
position as in birds are dinosaurs.
right. So what he's saying is, and correct me if I'm wrong, Sam, I like to point out the fact that you have a lot of, in the creation versus evolution debate or the battle of worldviews, you have a lot of what's called agnostic or non-discriminatory lines of evidence. And so an example of that would be like if I said, hey, evolution or creation's true because the sky is blue or the earth is round. You would say, well, that's not very good evidence because both models, both worldviews can account for that data. And so is there a line of evidence that only evolution can explain that's discriminatory and that precludes separate ancestry from being true? Because when it comes to classification systematics, sure, every creature is going to be more similar to another creature, and that might include the fact that humans are most similar to chimpanzees. It doesn't prove their relationship in the same way that birds today would be most similar to a theropod-like dinosaur. But again, that would also be agnostic to the overall ancestry debate. Is that basically what you're saying, Sam? And does that make sense, Dr. Dino?
I think I get it. Well,
and you could save that for your future debates, of course. We're not meaning to put you on the spot here or anything like that, because I think we'll have some good, meaningful discussions. Because when it comes to differentiating or discriminatory lines of evidence, I would argue that genetic degeneration that we've briefly discussed, which you said you're going to look into, I believe that is discriminatory lines of evidence. I believe that's not agnostic because I don't believe there's been a convincing response to that issue, which is contrary to evolutionary theory. There's Y chromosome data, mitochondrial DNA data. I think there's a lot of lines of evidence that are agnostic to the debate, as in they can fit in both the creation and evolution models. But then there's also several lines of evidence that only creation can explain or account for. And those are the lines of evidence that I specifically like to focus on to determine which model is the strongest. Dr.
Sure.
Dino, go ahead
So-
if you wanted to respond.
So just my answer to my question is just that birds are dinosaurs by the definition that we use to determine what a dinosaur is. Regardless of whether they evolved or not, they are categorically, anatomically, within the dinosaur group.
Yeah,
That
you're just
is
saying,
my answer.
You're just saying that we've created this semantic category, and we're putting things in it that look a certain way.
Yeah, that's kind of what
not-
my. Sorry, go ahead.
You're just begging the question. Let me give you a quick analogy. Let's say you had like 3 different shapes, but you had a whole bunch of each one, and these shapes were 3 different colors, and so you give them to 2 people. One person makes a category and puts each shape in a row, and the other person takes it and puts them in a row by the color. So you've sorted them 2 separate ways. So you're looking at the evidence through your presupposition, which is naturalism, and we're looking at it a different way. Do you understand that?
Okay.
Yeah, and what I was going to just ask you real quick too, and this is kind of to the point of what you were just saying. Categorically, birds have to be dinosaurs because X, Y, Z. My question to you would be this, and I would like to actually give you a little bit of like a insight on the Bible with it. Is I would say that science has needlessly yet purposely tried to make things more complicated than they need to be, because the more complicated you can make something, the more you can hide inconsistencies or hide biases inside of that like classification system. So what I mean by that is the Bible makes it pretty clear that you have like 4 general species of animals. You have the larger animal that are like cattle-like animal. Then you have the smaller animal that are included with like insects, smaller things that can swarm and team. And then you have your flying animals, and then you have your fish, or I should say sea animals. Well, if we read Leviticus 11, it actually, God gives you a natural breakdown of how you can classify these animals. Does it have a cloven hoof? Is it entirely cloven? Does it have scales? Right? Things that like can very easily be broken down and encompass the entirety of every single animal kingdom possible. So would you not agree that based on your classification, that it would, to an outsider, right? Let's say somebody who believes in God, or even maybe somebody who's just trying to learn about science and morphology, like you liked to. I'm sure you had an interest in it when you were little. Couldn't somebody look at it and say, hey, this seems like it's purposely made to be over contrived and very like kind of could sway either way to the right or the left, depending on what kind of narrative somebody would want to push?
Not with the broad categories of animals, no.
How come?
Okay. So animals can be broken up into several major groups. Here on land, we have the mammals, the reptiles, and the amphibians, along with a whole host of insects and some other things in between. Each of these groups is defined by features that all, or at least most of the group share, that are not found in any other group. As an example, all reptiles have scales, except for those that have secondarily lost them. All mammals have hair. All mammals produce milk. All mammals are warm-blooded. All insects have a hard exoskeleton, or insect may not be the correct term, but they all have a hard exoskeleton.
What about grubs?
Grubs? Well, those are just the larval stages of insects that have a carapace.
Does a butterfly have a hard exoskeleton?
It's not hard to us because we're really making it squish them, but it is to them.
So that's interesting. So it's
Oh.
so it depending on how, because we're humans and we're the ones classifying everything, but now we have to look at it from like a gnat's perspective to classify whether it's a hard exoskeleton or not.
I mean, we judge them based on their anatomy, so yes. And no, I'm not quite sure what you're asking. Like,
Well, like,
butterflies don't have a hard exoskeleton to us because we're much bigger. The same is true of ants and spiders, but they have an exoskeleton. That feature doesn't disappear.
So, but that's what's funny. So, what constitutes as hard? Is hard not a man-made concept then? Because what's hard to us, you're saying, is not hard to other animals.
Okay,
but
take
who's
away the
classifying-
hard. They have an exoskeleton.
Oh, okay, perfect. So now you can see how you can easily take away one word and it opens the door back up. Well, okay, I didn't mean hard. I meant they have an exoskeleton. Well, okay, there's probably plenty of other things that have an exoskeleton that you
Okay,
can say, well,
you're
it's not really an
picking at
exoskeleton.
an adjective rather than attacking the actual point. They have defining traits that are not found in other lineages.
Okay, so
That is how we
basically,
categorize animals.
So, Dr. Donny, you're basically saying birds are dinosaurs in the same way that humans are mammals, because
Yes,
there's
exactly.
certain like, for example, as humans, we're covered in hair. We're endothermic, and that has to do with how our body basically regulates our temperature and keeps it constant. We're also haplorine primates, right? We have a dry nose, and so does the chimpanzee, and also the monkeys. We're catarrhine because humans and chimpanzees and other primates have nostrils that are close together and directed downward. So now we're classified as,
And using a
hominoids
similar
and
system
hominids.
of shared characteristics, all
right.
birds are theropod dinosaurs.
Okay, so for
They-
the same
they just
reason,
are.
yes. So for the same reasons that I just gave you as to why taxonomists would say that we're mammals, primates, great apes, hominids, so on and so forth, is how you would say birds are dinosaurs.
Yes.
Right. So
That
certain
is the most
characteristics
vague
that
group that
group.
they can fit into while being excluded from all other groups.
Right. But my point is, in the same way that, and this is Sam's point too, in the same way that because humans have these specific characteristics that in terms of classification systematics, you could say we're primates, we're mammals, so on and so forth. You'd even say we're great apes. It doesn't necessarily mean or follow that all mammals are therefore related. That to
I'm
answer
not
that,
arguing for evolution. I'm just arguing for a categorical definition. I'm not
okay, a
arguing for
categorical definition. Okay. But if we were to, but it sounds like you because there are some even in the young earth creationist world that would say, and I disagree, but this is to prove my point that it's agnostic overall to the greater debate. They would say, yeah, birds are dinosaurs. They would even say that some dinosaurs had feathers, but they've looked to what's called baromenological analyses, and they've looked to these discontinuities using statistics and looking at various traits and features of the creatures, and they found discontinuities in the fossil record. And that they would say that they would conclude that's because of separate ancestry. So I guess my point is, I appreciate what you're saying, but in terms of the universal common ancestry debate or the ancestry debate in general, we would have to now dig a little deeper and ask the question: do these similarities, does this ability to classify creatures based on various traits, does this help us answer the question of ancestry? Is all life related, or is there separate ancestry? Does that make sense?
And I agree with you, but that is not the question I was asking.
Okay.
So I just wanted to ask the simple question for now. I was just curious and wanted to see what everyone's answers were.
I think it's a great question. I would answer it in a real quick way. I would say no in the same way that I would say no to our humans, great apes. I would say no, objectively no, because we're not related to the great apes, and I would go to a number of lines of evidence demonstrating that. But if you're just looking to taxonomy and you're saying these traits here make humans a mammal and these traits here put them into a subgroup called primates and a subgroup called hominoids and a subgroup called great apes, so on and so forth, then I think that's man imposing his ideas into the way we classify things. I understand you disagree with that. So if we could demonstrate that birds actually descended from theropod-like dinosaurs and were related to theropod dinosaurs and other kinds of dinosaurs, then I think we'd have more reason to say birds are dinosaurs. Anybody else have any thoughts on that, including you, Dr. Dino? Go ahead.
I mean, Brock's been putting his hand up for a while now.
Yes.
And he keeps getting talked over. I feel kind of bad.
Very
Brock,
patient.
Go ahead, Brock. I appreciate your patience.
Earlier you said, for lack of a better term, insect, because they have exoskeleton. Do you mean arthropod?
Yeah, that might be a better term. I am tired. I just had a 4 or 3 hour stream myself. But yeah, a arthropod. Yeah, I think that's the correct term.
Yeah, arthropodia. Yeah, that's the group name, and arthropods belonging to that. That makes sense.
Yeah,
pretty much everything. So.
I do have one curious question for Dr. Dino before we wrap it up, because we're now 4+ hours, and Sam and I, we've been here for the full 4.5 hours, so we're getting kind of tired. But my question to you, how do you view, Dr. Dino, the evolution of birds? Because correct me if I'm wrong, because it sounds like this is one of your expertise, is you have lizard hip dinosaurs and bird hip dinosaurs, right? Saurischians and ornithischians.
Ornithischians.
Yeah. Ornithischians. Okay. And so your ornithischians, those are your bird hipped. And then your saurischians, those are your lizard hipped. Yes. So, okay. So which group, which type did modern birds today, extant birds, evolve from?
Okay. First, from saurischians. And I can say that because in the fossil record, we have a very smooth gradient of small theropod dinosaurs with their pubis, the part of the bone that sticks, the part of the hip bone that sticks straight down. It helps delineate saurischians from ornithischians. In saurischians, it points downwards, and in ornithischians, it points backwards. We have this smooth gradient of the pubis slowly moving backwards as the dinosaurs get more and more bird-like. So they look similar in their hips, but they're derived differently.
So would this be an example then of convergent evolution? Because if you have your saurischians, which are lizard hipped, and then your ornithischians, which are your bird hipped dinosaurs, but you're saying the bird hipped birds today basically evolved from your lizard hipped ones. But then you also had your bird hipped dinosaurs. Did that bird hip have to evolve independently basically twice? Even more than that?
It did evolve independently at least twice. We're pretty sure the reason why it evolved in ornithischians was to make room for bigger guts, because the vast majority were herbivorous, so they needed more guts to digest plants. And for the bird lineage, it would have moved back farther to make room for bigger flight muscles, among other things. So they moved for different reasons, but achieved roughly the same result. And when paleontologists first found bird-hipped dinosaurs, they recognized them as looking like bird hips. So that's what they called them.
But the bird-hipped dinosaurs did not actually evolve into the bird-hipped birds today. The bird hip.
They just got called bird-hipped dinosaurs because their hips look like bird hips.
Was that predicted before the discovery in the fossil record of these?
No, they were named. I'm pretty sure they were named before evolution was even really a concept.
And that's why I find, and that's why I find the fossil record, although interesting, I find it to be very indirect. Very indirect way to answer this question of ancestry, because I find there's a lot of inferences, there's a lot of storytelling and historical reconstructions, but the genetic data, the biology data that we have today, I find that to be more of a direct way to answer this question of ancestry, and therefore more useful in providing us discriminatory lines of evidence.
I actually completely agree with you. Bones can lead us wrong, but as time has gone on, we've gotten exponentially more fossils to work with, which has really helped fill out our view of the past. And in fact, in just the last 30 years, we've gotten tons and tons of small feathered dinosaurs that we never knew of before.
Wouldn't you call that super convenient?
No, I'd call it Jurassic Park came out and people became interested in dinosaurs again.
I would call it super convenient personally.
No, it's actually called the Jurassic Park effect. You can see a public interest skyrocketing after the movie came out. So paleontologists got a ton more funding. They could do more digs, and they found more specimens. It's pretty simple. There is no conspiracy.
It's not necessarily a conspiracy. I find that I could take some of those points and have a discussion for another 3 hours. So I'm going to actually refrain and we'll set up a future discussion because, again, Sam and I, we've been going for about 4.5 hours. And this has been a great discussion. It's been really enjoyable. We're going to do another one. We like to do a lot of open mics. The evolution open mics, we tend to do about once a month. And it's always the same structure. We'll have Kent on for 2 hours roughly, and then we'll go for several more hours. But
I mean, feel free to put me in a debate about dinosaur evolution. That'd be a lot of fun.
Can I ask a question before we go?
So I think Ruben had one last question. Sam, I feel like you wanted to say something there, though, before we get to the last question, because I saw you on mute. Did you want to, brother?
No, I'm good.
Okay. So let's get the final question for the night, and then we're going to wrap it up. This has been a ton of fun. I love these open mic debate challenges. Us on Team SFT, we like to put ourselves into the hot seat, and we like to, engage our critics or non-critics and basically give people the opportunity to challenge us, bring up various topics. I really enjoyed discussing taxonomy briefly there with Dr. Dino here. And so all are welcome as long as they, remain professional, cordial. We don't mind passion and people bringing the heat, but as long as we keep it sophisticated. So, Ruben, go ahead. We'll kind of wrap this up with a final question from you, my good man.
I just wanted to ask how creation explains like dinosaurs and like how they got extinct.
How they went extinct? That's a great question. Sam, did you want to take that one, brother?
Yeah, I mean, I think there's a lot of excellent reasons to explain that. I mean, look at the buffalo that roamed the plains of North America. There was a lot of them, and so they would be a prize to kill for one. They would provide a lot of food for two. It's possible that they could have been utilized just in the same way that the American Indians would utilize certain things. We would also say that after the flood, the environment would change a lot to where their survivability would have diminished. And I mean, I think there's a lot of reasons why.
Were they in the Ark?
Yeah.
Well, fair enough then.
So I would say no. Personally, I don't think they were in the Ark. And I would actually say that dinosaurs aren't as big as science fiction propaganda wants to make them out to be. It's been proven time and time again that these archaeological digs find bones hundreds of meters apart, sometimes mile apart, and they'll be like, yep, these all go together. So they've been reconstructed kind of maliciously.
Sorry, that's just not true.
Well,
that is not true. I've been on plenty of paleontological digs. That is incorrect, sir.
Well,
yeah, they're.
I can tell you it's not.
I mean,
incorrect.
I would say. Well, hold on. I mean, I would say that you guys are both right. I mean, of course, they find bones that are spread out, but you can see pictures of dig sites where they are intact. But you wouldn't have to put a full-grown dinosaur on the Ark. You wouldn't have to put a full-grown anything. In fact, you'd probably want something that was extremely youthful, because the goal would be to, after the flood, they would get off and they would also be fruitful and multiply and replenish the earth.
So would they just like die to natural causes then in lots of different ways?
As long as you got a pink one and a blue one, you're fine.
Yeah, right. You need a pink one and a blue one. We're not confused about that. If that would have happened today and there was confusion, then it's possible that we would have all got, all pink ones or all blue ones, and it wouldn't have worked.
What if the species is hermaphroditic?
But yeah, so as far as the extinction of them, yeah, I mean, I would think they most likely would have been hunted off. Now, we have records of dinosaurs and man. Marco Polo wrote about them, for example. We see images of them on hieroglyphics and such. So, they're engraved images and ancient runes. And Marco Polo wasn't the only one who wrote about him. In fact, I believe it was the Chinese dynasty. There's writings from the Chinese dynasty that explain that they had a division of their army that was specifically set apart for feeding these. They would ride them into war. There's actually old pictures of images of people doing such. So
have they
you
found
gotta-
fossils with humans and dinosaurs next to each other?
Well, if I could respond real quick, and great point, Sam. We did a great presentation. It's got a lot of good feedback with Dr. Dan Biddle, and we did. I think you joined me, Sam.
I
And
did.
He documented this amazingly, probably some of the best that I've seen in slide form. And so he presented, it was about the last 20, 25 minutes of his presentation on dinosaurs and man. And he went into the countless artifacts, the drawings, the carvings, the statues, the mosaics that basically depicted throughout history dinosaurs existing with man. The pictures of, Brachiosaurus, Plesiosaurus, pterodactyl, triceratops, so on and so forth. And he pointed out that yes, some are frauds, some are fake, but he pointed to ones that would be very troublesome to try and say that they are frauds and fakes. And so I'd recommend people check that out. And Ruben, I'd recommend that you check that out, especially if you want to see the actual pictures and documentation.
Could you put that link in the chat so I could check it out after?
Absolutely, brother.
Did he bring up the Glen Rose tracks?
No, he didn't. I know that's a controversial one. So he left the controversial ones out of it. Dr. Dino, I think you'd enjoy it. And then maybe you can critique it after you watch it. But I would say post-flood changes in environment and the climate would kill off a lot of the dinosaurs, lack of food, a lot of the disease. Remember, the entire real estate on the earth was changed after the flood. And the environment would not be as suitable for a lot of the creatures that thrived in the pre-flood world. And so a lot of these creatures would become extinct, but we see so many legends of princes and warriors killing dragons. We see a lot of historical accounts documenting, Alexander the Great, Marco Polo, like you said, Sam, Herodotus, for example. They documented cases where they encountered dragon-like creatures. In the same way we don't want bears living in our backyard, they didn't want a T-Rex or an Allosaurus living in their backyard in the post-flood world. And so I think a lot of them were hunted, a lot of them were killed. And I don't think we need to find the dinosaur bones right next to the human bones, because we've got the historical accounts. We've got the artifacts. We've got all of the evidence that we need to show that if man depicted dinosaurs, they must have existed with them. And you don't just find the whole dinosaur specimen in its entirety just sticking out of the rock, right? Because a lot of evolutionists have said, well, they found the fossils and so they depicted it. Well, no, you don't find it intact enough where they could depict it in the way that they have. Anyways, I hope that helped. Ruben, if there's a follow-up, Brock, I know you were going to say something.
I'll let Brock go first.
Earlier, like 30 minutes ago or more, somebody said that evolutionists believe that a T-Rex evolved into a chicken.
Mm-hmm. Yeah.
I don't think I've ever believed that when I was an evolutionist. Obviously I question things now, but I don't think anybody believed that. I think
you have to, though.
I think that birds came from a separate arthropod. Theropod, and that theropod was Archaeopteryx or Microraptor, one or the other, and then the birds come after. So T-Rex is a separate lineage that went extinct. That's their idea. That's so I don't think when people said it right. So
don't you think it's
what they'll actually? Well, I'll just say what they'll actually say is basically certain modern birds today descended from T-Rex, and they don't necessarily know which modern bird, right? Could be a chicken. They'll say that chicken or T-Rex, I think they look at proteins obtained from connective tissues in a certain T-Rex fossil that they say has demonstrated a relationship to modern birds today, including chickens and ostriches. But they, I don't know if they would say, well, the chicken today directly in this nice linear line came from a T-Rex. They'll say that some modern birds descended from a T-Rex, but they don't know which ones. It's probably just their way of not admitting that, yes, they believe a chicken came from a T-Rex.
Right.
I don't know if they actually do believe that. I don't think they actually do.
Brock, here's my question for you. And this is pretty much what I was indirectly trying to get at with Dr. Dino. Let me ask you from a moralistic standpoint, okay? When somebody is telling the truth and somebody is telling a lie, on average, how much more convoluted is the lie than the truth?
What do you mean by convoluted? I'm confused. What does convoluted mean? I forgot.
So like, no, like how many more steps do you have to get from point A to point B between like when something is the truth and something is a lie?
I don't know.
Really?
I don't remember all that.
Would truth take a lot more steps?
Well, so
maybe because they would actually know what they're talking about. They'd have more of it discovered than they probably just made something out, right? Maybe.
Let me bring it to you like this. If you, let's say you wake up for the morning on time to go to work, and you get ready and you arrive at work, and nobody asks any questions, but let's say you're out too late one night, tied a few off, right? And you wake up late, and all of a sudden you're scrambling in your brain, what am I going to tell my boss so that I don't get fired? And then all of a sudden you've got this story of, well, my dog got sick and I had to take him to the vet and my phone was dying, or I got in an accident on my way home or on my way to work, and it was all this stuff. Like, would you agree that that's kind of what people tend to do when they get caught with their hand in the cookie jar?
Yeah.
So they're going to exaggerate it more if they have to lie. Is that what you're saying?
Correct. Would you agree with that?
Maybe, I guess.
So that's my whole point.
I'll just point out.
I could have sworn the evolutionists. I could have sworn they believe that there's like a theropod, and theropods split into two. So the T-Rex over here, the T-Rex dies out, and this is where the Microraptor is, and it splits off into different bird species.
So what was the exaggeration? What's that linking to as the exaggeration?
Just how this entire classification system of like evolution has to literally take like miles and miles of grains of salt to just try and justify, well, this is how we got from here to here. It seems like it's just really on purpose, overly complicated. But I take the same stance with a lot of science. Like, you talk to an astrophysicist, they're going to have all these equations where you're like, hey, those equations are great, magnificent, we love that for you. But it doesn't mean that it's right just because you can put a bunch of little numbers and exponents next to letters.
I'm not saying it's right. I'm just saying that's what they believe. There's like a theropod, and it splits
hold on, let me
into
touch on that.
The T-Rex goes extinct, and then the Microraptor that came from the theropod like splits off. Some of it lineage survives to become bird.
Brock, here's the problem. When you reject biblical creation, you have to. It's not, evolution isn't like a salad bar where you get to pick and choose. They bring the plate out and you eat it. Doesn't matter what's on the plate, however absurd, that's what you believe.
I'm sad Dr. Battle left because I wanted them to hear that.
Because you reject that truth of biblical creation. So, Donny, brother, what do you say? Are we, is this a good point to pull the plug?
Yes, everybody, great job. It's been a ton of fun. We went 4.5 hours. It doesn't feel like 4.5 hours, but this has been a great night in the debate dojo. And so, Sam, great job, brother, hosting. Also to Matt. Matt lasted most of the time. So it's been great for anybody.
Matt, his camera fell down and it shut off. So I hope he's okay.
Yeah.
Let's just pray he's okay.
I did just want to like end off or sign off on this note. I know that if we on a scriptural note. So
sure.
1 Timothy 1:4, Paul is describing genealogies related to, hey, I descend from, this person, so therefore I'm part of this Israelite or Hebraic lineage. But I think it's a good analogy to make where he says, don't give heed to myths and endless genealogies, which only bring speculations rather than stewardship of God, which is in faith. And I think that's my main point. If we have faith in God, you don't need these endless speculations and myths of evolution to, it just brings about nothing. The truth is there in the Bible.
Yeah. Amen.
Okay.
I'm not sure which one to believe.
All right. Well, we're going to wrap it up there. Thank you, everybody, for joining us. It's been a packed house. We've had a lot of great guests, a lot of great questions, a lot of back and forth debate. I think we've had a solid mix tonight. So we will be doing another open mic sometime in the next probably month. And so people make sure to look out for that. Again, to my hosts, Sam and Matt, thank you. As a team Stand for Truth, we like to put ourselves into the hot seat and allow people to come in, ask questions, challenge us, so on and so forth. So to the audience, thanks for tuning in. We've had between 120 and 170-ish people the entire time. So share this content around. I've had a ton of fun. Sam, you deserve the night off, brother. God bless all. Standing for Truth.
I enjoyed this so much. Thank you so much. I actually came home in the rain because I was excited to see what's happening. I was like, oh,
I'll be looking forward to talking to you soon, Donny.
Yeah,
yes. Professing Preterist, I've got some upcoming debate opportunities for you. So I will, you'll be getting an email from me shortly. Okay.
Oh,
God
boy.
bless all. Standing for truth is out.